Okay, welcome everybody to Dallas Personal Robotics Group. We got Robot Builders Night online called Virtual. Tonight's the 17th of February, and we'll just do the usual thing of going around the table, have a little bit of information midstream to talk about for the contests, and then maybe a little bit of questions about the recording that we make and people's thoughts on that. But until I pull up some notes on that, why don't we just get started with the usual? And I'd say, Doug, if you want to just get going, and then after that, we can have Chris give an update, and then whoever else wants to give an update after that.
I'm good.
All righty, take it away.
I'll start off with presenting. So it should be coming up. On my blog, I finally finished my second blog, and I finally got Roby running. Oh, I think I'll show the video live instead of from the blog. Here's the video of my robot actually using his pseudo, well, I said it was, using his pseudo subsumption module. Well, here we are at the big finale of the blog, at least of this blog post. Got both of the ultrasonic sensors in. They're not locked into place yet, but they're in the holes. They're wired into the Mega, and everything is ready for me to practice some object avoidance. So we're going to see if Robbie's base can handle that. Right now it has a very simple program. When it sees something, it backs up and turns a little bit. So the object avoidance sensors are working. The basic program is working. Oops. Sorry, I closed that sharing before I mentioned the code is on that blog post too. If anybody want to look at the code, it's very simple motor control left and right, and just using the SRO4s to look at distance, and it shows my pseudo subsumptic programming where it's looking at the sensors, and then it's deciding it has a hard stop if it finds something too close. Otherwise, it sends up to the higher level program, which is right now just not really implemented. I'm doing it inside that program because I haven't got the conversation between the two computers working yet. But that lets the higher program say, "Oh, let me back up or turn or something like that." So I'm making progress. Still can't get the base on there because I still have. I think you can see the robot base here. This Mega was too far forward. The thing was bumping it, so I stuck it up, and now it's still bumping it. So I'm going to have to decide better measurements on how to set that thing down, but it's doable. I just keep messing with it instead of measuring it first and doing it right the first time. But that's basically where I'm at. Got my second blog done. Going to work on my third blog, which will be to make it so I can get the base on there. And then I'm going to start working on trying to connect the Raspberry Pi in and deciding on which of the multiple types of connectivity I want to use. I think I'll probably not use the I2C. I'll probably end up with the SPI or maybe the UART. That's it for me.
Doug, you got the multiple thumbs up on that one. I was looking at, there was thumbs up all around the page here.
Yeah,
That's pretty good.
Question, the motors, I mean, they sounded loud. Maybe it's just the way the camera picks up the sound, but
they are loud motors. They're cheapo motors that are inside this box here, and inside this box. They're old 1985 motors from Radio Shack, actually from Tomei in Japan. So I don't think they were designed for quietness. They are what they are.
Okay. And that robot blog, that's you own that domain, or is that some website that you can just use your own, you have your own space on?
That's I own it, but I offer blog space to anybody that wants to program or blog about robots.
Because it reminded me of that. There used to be Let's Make Robots, which I think then was bought by the Robot Shop company. But there was a big blog website that I occasionally checked in on, and a lot of people sort of were able to chime in. So I'm not quite sure what happened to that, other than Robot Shop bought it and turned it into their forum or something like that.
Yeah, I think I have some competitors, but being a website programmer, I decided to just put my own up and then see if anybody else was wanting to play too.
Hey, Doug. Question, Donna in Seattle. So first of all, great job on putting that blog together. So which kind of landing page or site builder software did you use to build this out and then attach your own domain name? Just out of curiosity.
Well, I program in ASP.NET, which is Microsoft, and I have a host that I usually get a domain from, and I pay by the year for the hosting the site, and then I just program the pages.
Okay, so in other words, it's probably a WordPress site then.
Oh no, it's ASP website.
Oh, okay, all right. Huh, interesting. Okay, good job.
Thanks. It's still a little rough, but it's functional at least. I'm still prettying it up.
So the code, you said the code is on there. I think I found it. So you're not using GitHub. I guess that would be one suggestion, something everybody should get used to. I know there's a learning curve to everything, but it's quite useful.
Yeah, I need to get more used to GitHub. Everybody keeps saying that, but I thought, well, what the heck? I'll just post it here for now. Of course, it's a text file, and you have to cut and paste it into your Arduino editor or editor of choice. So GitHub would be a better thing.
One thing I found it useful for, apart from just being able to go back to older versions and things like that, but I sometimes have a computer in the basement and then a laptop up here, right? So depending on the situation, right, I might be working on one computer or the other, right? And so rather than just sort of haphazardly copying files around, I find myself just using GitHub, as my own central repository that I can access from more than one computer.
That's exactly what I was thinking. I've just been lazy about learning it. I've toyed with it here and there, and had beginner frustrations in trying to get what I wanted to get done when I really wanted to get something done instead of learn GitHub. Sometime I'm going to take the time to actually get better at GitHub so I feel comfortable doing what you said, because that's where I want to get to.
Well, Doug, there's only about 4 or 5 commands, actually. There's git add to add your files into a repository. There's git commit to commit those files, and git push, and then there's a pull. And it's really pretty trivial setting up the thing on GitHub, there's lots of help on that. But the big advantage, as Chris said, is I think I can do a status update on my robot. I think I blew my Raspberry Pi. So when I go to replace it, I could start from a new Raspberry Pi with a SD card, get it all running. That takes a half an hour. And then if I basically do git pull with the URL, it'll load my operating system onto the Raspberry Pi. And the first time I run it, it'll be there.
Yeah.
And it means you can't lose code. That's the big benefit.
Yeah, that's what I want to get to, because right now my code is backed up on another hard drive as my backup procedure. And I'd like to have some cloud backup like that. And also I program on multiple computers, so it's just easier to not have to copy the code between them.
Yeah.
See,
I'm lazy about doing it.
I like those aspects of it, but I find the true power, the real value of it is a step or two beyond that, which unfortunately requires a little bit more of a learning curve. And that involves advancing, taking little bites out of a long project. right?
Hmm.
So I'll take little bites and little bites and little bites, and at some point I'll get something stable. So I'll park that and I'll use branches. So the next after you get the basic push and pull and commits, then comes branching, right? So I'll say, okay, this is a nice stable part. So I'm going to keep that right where it is because I can always go back and I know that works, how it works. But I'm going to start dabbling now and add a new feature. So I'll make a branch off of there. I'll say, okay, on this branch, we're going to add IMU. So this will be the new IMU branch, right? So I'll start there and I'll start adding, okay, let's read X, let's read X, Y, and Z. So I'll just add commit on commit on commit. At some point it'll work and at some point it'll break. So at some point it'll be good enough that I'm happy with it. And then I can merge it back into the stable branch, right? So what I really like is being able to, like right now, I might have 2 or 3 different things pushing in different directions, but I know where they are, and I can inside a Visual Studio Code, you know, a free editor. There's a plugin I really like because it makes it really visual, and I can say, okay, if I go take the level, if I don't understand why this worked and this didn't, so I can say, well, let's take that commit and tell me Visual Studio Code in which files did what lines change.
Right.
And it's just as easy as can be that way.
Yeah.
And
Riding a bike is easy too once you've done it a couple of times. It's that first learning part.
That's the hard part, right? Because then,
yeah.
I mean, all you got to do is try one of those things that talks about, just issue this command, and then you have a detached head, and you go, what in the world is a detached head, and why should I care?
Yeah.
When in fact it's an easy thing, but
sounds like a topic for a monthly meeting, right? For someone to sort of, oh, you had, okay.
Well, we've touched on it a couple of times, and people are starting to dabble, but it really, to do it, you got to just sit down and be committed to try it, right? It's like the line follower. Until you sit down and download processing and download LFS and try and change a couple of lines of code, you got to trip before you can figure out how to walk, right?
Yeah.
I'm sorry, I had to step away and talk to the wife for a minute. Are we talking PID controllers yet?
You would have thought so.
Not yet, Harold.
It's either PID or it's KID. It's one of the two, isn't it?
Actually, I can suggest one thing is if you Google on Hello World GitHub or like Introduction to GitHub, there's actually a guide called Hello World, and it actually steps you through creating, because what you want to do is create a repository and then put things into it on GitHub. And there's actually like on GitHub itself, I'll see if I can add the URL into the list here. I'm on a different computer with that, but it's actually not really hard, Doug. It's almost trivial.
Oh, here it is.
I expect you're right about that. I had some concerns about what Carl was saying because I need to get to that point too, but I think it's all doable. I just have to spend the time, and I was busy doing other things is what my excuse always is.
Well, I work in a professional development environment where there's branches and forks and all these things, but you don't need that. You really don't. Not to get, you could spend a year easily. Like Carl's making it way more complicated than it is. I on mine have a ROS. I have my own ROS. So I've got GitHub / my login name ROS, and that's the URL, base URL. And I created that repository. And then you just add files. You can do a status to see which files have changed. It's pretty straightforward. It's only like maybe 4 or 5 commands. It's pretty easy. Unless
you're getting into some advanced, a little bit more than just you, yourself, and you.
Right.
Mm-hmm.
Work. That as soon as you invite somebody else or invite or allow other people to give you their ideas, as soon as you do that, and then you need to set up pull requests because you don't want those people pushing stuff into your baby without your approval.
Right.
And that comes down to. So if all you're doing is just doing your own work, doing your own thing, man, pushing the master or pushing the main, whatever politically correct damn thing you're supposed to use these days, push it in there and just go with it. You know, you don't have to get crazy with it. You certainly don't.
No. Carl went to rocket science right away, but
Harold and Murray, I'm going to go with you with one minor caveat, and that is that I have a team of 3 because just with me, myself, and I, in the current tense, the past tense, and the future tense, I don't even know how many combinations that is, but I can't keep track of myself. So
I didn't realize you had such a pathology.
I
Yeah.
find things on I find some things on occasion that my past self has realized my future self is going to be an asshole and did things over here that made me not be quite as big of an asshole in the future. So
see that?
it's helped, you know.
Oh my. Oh my.
So in my world, all those different combinations, those are different people. So I got a big team just going on right here.
I believe it actually.
So a quick
Hey.
question for Chris, because last week we mentioned a behavioral-based book, and I think I found it on the internet, but I wanted to make sure I had the right one. That was Joe Jones. I wrote David Jones.
Joseph Jones. Yes,
Yeah,
that's
that's the one. Thanks. I am going to get that because I think
Yeah,
that's
that is an awesome. That's an awesome book. I've read it myself.
Yeah, actually, David Anderson recommended I buy a copy as well, and you can get it as a PDF, I think.
Which
Somewhere.
one's that again?
Kindle or a paperback, but probably other ways.
Yep.
By Joseph Jones.
Can you
Yeah.
put a link?
Good to know.
Hey, Carl, just a question about your mention a little bit ago about that Visual Studio plugin.
Yeah.
I think you were talking about a visual, visual editor or display plugin for Studio that helped you with GitHub commands, or could you provide some other information on that?
Yeah, sure. So so I'll just do a quick presentation. Screen 2. Okay, and it's coming up now. Should be, there it is. All right, so this is Hover Sim. So this is the physical robot, not Hover Sim, the line following virtual robot. This is Hover Sim. So it's a Arduino project, and what you can see in here is that I run Control-Shift-P, and the plugin I use is called I don't know what it's called. Let's look it up. I have 2 plugins for Git. I have the one I use every day and the one that Steve Edwards recommended, which is also good. The one I like is this Git history one right here. And it's got, quite a few downloads and a lot of stars. There's a couple of little goofy twerks to it, but quirks. This one has twice as many downloads at 7 million, and I think it's also equally awesome. I just happened to get started in this other one first, and it's been keeping me going. But like, just to show you how it can work. So like on the left-hand side, these are all the files that I have. And I'll get rid of this window, and I'll get rid of these windows because I don't need them right now. I'll just shrink it down. So all branches. So like here are the files on the left-hand side, and you can see right now I have this dev branch checked out, but you can see that I have quite a handful of branches in here. So of course there's a bid stuff branch, and I tend to keep I got merge kind of like or dev is kind of up to, it's the latest right now, but it's nice because I can go in here and say, well, remove that comments so I can view against the previous, and right there's the stuff I pulled out. That's kind of handy. Or I can look at like added mechanism to calculate encoder ticks. Okay, so what was involved there? Well, that was these. Like I had my design documentation PDF changed, PowerPoint changed. I keep track of that. There was just a few changes in this one and H and drive calibration. So, it makes it really easy to look in here and see, well, oh yeah, that's what I did in this change. I added that and added that, got rid of a line. So it makes it really, really easy in a way, right? And then I can ask the question of, well, what's different between this LCD branch down here? So like this particular commit, the commits go in time from the bottom to the top. So here, this I know because this is where I added the LCD display to it. So I can say, okay, select that commit. All right. And then from this point in time up to my current, what has changed? So compare, and then it shows up over here under compare commits. And I can see that, okay, like on drive calibration H, I added these defines. I added that code. Right? So I can really quickly see what happened between any 2 points in time. There's the main, I defined a new test point, visual test point. So it just for me, it kind of like takes a lot of the guesswork out of what was I thinking a month ago, the last time I had an hour to do something. And I can say, oh yeah, so now I know that that this is the branch where I was doing things related to the LCD. So suppose I wanted to like turn this stuff into classes, or maybe I wanted to add some more functionality that was just specific to the LCD. Well, I can check this branch out just like this. I can say, check out the LCD branch. So now the file set over here, the file set in the file system matches this point in time from March 22nd, okay? And I can say, all right, now what I'd want to do is bring that branch up to speed with the latest, so I can pull all those changes into that, and then I can start working on the LCD again. So now I can keep track of all the things related to the LCD in one place.
Wow. Well, that's impressive.
It is, because he obviously has a ton of discipline in doing that, right? And that's what's required, right, to really get the most out of it. Because if you make a ton of changes and say, oh yeah, okay, now I'm gonna push the changes to GitHub, but if you made half a dozen unrelated changes, you kind of really lose the value. The key is to break it down into small incremental thing, right? You're doing one little thing.
Right side bits.
You gotta commit it. You gotta commit it.
Focus.
And then you're making another change, and then otherwise you don't have that trail of evidence here, that history. If you don't sort of, make it in small chunks, you won't see that.
Pretty much the thing we use is your commits should be like in Despicable Me, the minions. They should be small and numerous. So you basically, hey, I make this one change. Ooh, it didn't blow up and it came closer to what I wanted going. Commit that, push it up, and go on again. And it's okay. They're free. They're cheap. It doesn't cost you any money to actually make the commit. And now you've saved your little bit of history in a little bitty bite-sized chunk to get closer to go.
And you can make long comments too, right? I find this helpful because, if I only have an hour or two, I want to make some progress and leave things in a decent state. So at the end of that hour or two, I say, okay, I've done something useful. That what I did is now solid enough. So I just make comments in here, like, look, the LCD now does this. The backlight kind of works. There's still an issue with those two characters missing somewhere. I don't know where they are, but anyhow, it's just to kind of note to self in the future, because it might be another week or two before I can get in again.
Mm-hmm.
Well, I'm looking forward to the Git version for hardware, because I just got, I just have to back out all the changes I made in the last week.
Yeah, I know what you mean, but well, I guess if you were working in raw silicon, it exists because it's called Git, but I don't know.
Yeah.
Hey, Carl, how did you get your other stuff into Visual Studio?
Other stuff meaning what? You've muted yourself, Dave, or somehow you got muted. Dave, you're still
all right. There you go. Okay, you're doing all this in Visual Studio, right?
Visual Studio, right? Free editor.
Okay, but you're doing. Okay, you've got your other stuff that you've moved to Visual Studio that isn't standard C.
Oh, it doesn't matter. I mean, Visual Studio Code is a multilingual kind of a thing. I mean, look at this.
Even the traditional Visual Studio, right? I mean, happily open any file. I mean, that's, it's at the end of the day a text editor. If it's a language it understands, it'll do syntax highlighting. If it doesn't, you're just looking at plain text.
Well, and it has even better than that. It has where I have not in this repo, But it has plugins for viewing PDFs and SVGs and things like that. So, and like even README, it can be, I can open a markup. Here's a markup MD file, and you can view it as a raw markup, right, with the pounds and all that kind of stuff. Or you can view it in preview mode and just right-click preview because there's a plugin for that, and there it is.
Okay.
So it can do HTML, Java, processing, C, JavaScript, Python. I mean, there's hundreds and hundreds of plugins for different languages.
Oh, talking processing, are you? I mean, I've installed some processing plugins into my Visual Studio Code, but I don't believe it's possible to actually run the whole thing within there, right? You're just using it as an editor, or have you found a way to actually run it and debug it from there?
I don't know about debugging. I still haven't really used the debugging facilities in here. But there are definitely, I saw some things in here for processing where you could launch it.
But have you actually tried it, or are you just using it to edit your line following thing?
Right now I'm using it to edit, and I got disappointed because IntelliSense didn't work.
Yeah.
IntelliSense works for Java, but it doesn't seem to for the processing dialect. But this is the plugin I've been using, Chris, and I'm pretty happy with it in general. I'm just disappointed I can't find an IntelliSense thing. So it doesn't like pull out. If you pointed a symbol, it doesn't tell you where that symbol was defined. Unlike here, like in C, what's cool about it is I can look, if you hover over that, see that?
Yeah.
If
Yeah,
you
that's
hover
what
over
Visual
it,
Studio Code is really good at, right? All the syntax highlighting and the
oh yeah,
and the
and
cross-referencing.
you can find all the references just in a click. Yeah, there's all the places where active drive calibration is used, and it'll just go to whatever place that is, right? So you can go to the definition, you can rename the symbol, change all occurrences, go to the declaration, go to the definition. That's, there it is. That's
Impressed.
So Carl, which version? I mean, I know you said it's a free, one of the free version of the editor, but which version specifically of Visual Studio is this?
VS Code. This is
Visual Studio
1.5.1.1.
But it's Visual Studio Code. I think that's.
Yeah, so you just go with the latest, right? So it's not 2019 or 2017 or 2015. They don't version it. They don't, it's a whole different product line from Microsoft. So there are similarities, but more differences than similarities between that and the regular Visual Studio.
Right.
Which sometimes I still prefer, to be honest. I find Visual Studio Code, it has its own, the way you kind of rearrange. You don't have as much control over how to rearrange the tabs and how to make use of the screen real estate. It's not good as the regular Visual Studio in making use of all the real estate.
Yeah.
But other than that, it's a good editor.
Yeah, and you'll get updates on this, I don't know, at least once a month. I'm on the Canary branch on mine, so I get updates on a weekly basis because I like to live on the edge, but you don't have to. Even if you're not living on the edge, they have monthly updates. You'll get updates every month and be on the latest stuff. And you could choose to accept them or not, but I generally choose to accept them as well.
So I'll tell you, I accepted everything until I hit one snag, and so now I give it pause. But here's the thing: so Microsoft has this Arduino plugin, and it's pretty cool in a lot of ways. It connects to your Arduino environment. IDE, but you can do all the compiling and everything from here and push it to the device and serial monitor, and it's really nice in a lot of ways. But then you can even edit the board library and select different targets. And I've understood, but I've never tried it, that if you have one of the like JTAG programmers and things, you can actually attach the JTAG programmer to VS Code and single step through your code using the using this plugin to Visual Studio Code over JTAG. I mean, it's pretty wild.
So
But
that
the
plugin
only-
is a little bit like the Platform IO plugin then, just Platform IO is a little broader in scope maybe.
Yeah, probably. But the only downside that I would say for this whole thing, the only reason to be maybe a little careful about updating to Visual Studio Code everything is that sometimes whenever they make an update, they break the serial monitor. So it's normally quite nice to be able to run the serial monitor from within the IDE, but except when they break it, and then that point you have to like roll back. So like if I hook one up right now, Arduino, let's see. I guess I don't know which commenter it is. Yeah, it's not running. So I was the wrong speed, but you know, everything you can do here, you can just, yeah, I haven't run it in a long time. So, but anyhow, it's normally that easy when it's working. So you can do everything within. Okay, I'm going to stop babbling now because I've really consumed. We've gone way beyond PID and what was the other one? Git. Now we've gone into Visual Studio Code Editor. So unplanned presentation. Okay, so who Chris? I think I somehow managed to sneak in between Doug and you.
No, it always works out that way. Yeah, so I don't have much. Let me. Oh, hang on. What?
Quick question. What was the GitHub short course thing that you were referencing?
It's
I posted
in
the I posted
the
the
chat.
URL into the list.
Okay. Thank you.
Oh, Carl beat me to it, I see.
I can copy from the best.
So let's see. Let me know if you're seeing my course,
Yep.
my LFS
Oh, you
course.
bum.
Okay.
He's
So
gone.
now what I wanted to highlight here is, and actually, see, the thing is, I'm getting real frustrated because I'm still stuck in a couple places, and I have been at those places, and I'm not making progress, and I'm really frustrated with myself. And you know, I kind of highlighted the places, you know, the gap and the gate I can't tackle at all at this stage. Those S's, you know, some of them I'm traversing fine. Others, you know, it's just going straight through. So I have a feeling Doug Paredes is going to object to me just going straight through the S here.
Yes.
Um,
No ballistic. He's going to be on your tail.
so I know I got to fix that, but you know, but you know, that gap and the gate, I'm just stuck. I'm going in circles, and so I don't know, getting frustrated. And
Well, I wonder if you need to change your sensor arrangement or something. Maybe that would help you. Even if you use a different sensor for most of the course, what about adding some other sensors? And,
yeah,
and
it's what I
using
have
those?
been. I mean, I've got more lines than I have fingers, right? I have more lines than I have fingers at this point, and so I have plenty of sensors, and I'm playing with their arrangement, right? And I added and thanks for fixing that issue there with the, you know, vertical
Sensor
sort of line
location.
sensors that are parallel to the wheels. I got those, and I'm playing around with all the different arrangement and positioning, and just to get a sense of what positioning of sensors makes sense. But somehow I'm still I don't know why I'm still sort of stuck there at that particular corner. You know, again, it's what's tough on that one for me is as it gets into this corner here. I don't know if you can see my mouse cursor, right? I'm again sort of picking up then the transition between black and white, right? So it's getting confused there,
Yeah.
losing track of the white line, and I gotta improve my line detection logic so that there's too many cases where I don't pick up the center of the line correctly, you know, and a lot of times it doesn't matter, right? Because if for a short period of time you pick up the wrong thing, yeah, it goes a little off course, but then, you know, you find the line again and it keeps going. But in some places, even a couple time steps of confusion, a couple time steps worth of confusion is gonna sort of make me, just go off course completely into no man's land. And that's
Right.
where I'm at with that particular corner there in E3. I'm just, yeah, I mean, if I slow down, I know I'm going to have to slow down. So I have to add logic. Hey, when I reach the intersection, just slow the hell down, and okay. But then still that transition, if I make it through that corner fine, that transition then here from white line to black line followed by a gap, what has to happen, right? By the time I reach E2, I'm going to have to be aligned with the line because, right, if I see no line, okay, just go straight. What if I'm at an angle and go straight? That's it.
Well, I guess the question is at that point, if there's anything in your visual field, and I know it's pushing it because you can only see about 6 inches ahead of the robot. So I guess you could look to see, well, what angle you're at there. Yeah, it's a toughie. I guess I don't know where I am with it. Well, I mean, I've solved it, but I consider my line follower not very stable. I mean, I can run it, but I'm worried about it, especially as I want to make tweaks and try to speed it up, especially when you told me you made it to that intersection in 20 seconds. That's got me worried. Now I got to run this thing to full speed and figure out how to control it.
You lit a fire under Ron's butt.
Yeah, that's
So
right.
He's got a bunch of fires lit. So Chris, at risk of playing the pool hustler, how long does it take to get all the way around and leave the little green cookie trail that you've got? Is that a secret, super secret?
Well, let's keep that a secret. And again, it won't make it, right? So I'd have to sort of calculate the number based on, or I can do this section. Then I have to make an assumption how long it's going to take me to carefully traverse that gap, right? So I have to make a couple assumptions. I could give you a number, but I don't want to, right? Otherwise, otherwise you might just give up at that point, right? If you hear the number, you're probably just not going to bother. So
It's 12 seconds.
The game is on. The game is on. All
just
right.
figure out, okay, let's see. The robot can move 36 inches a second. Figure out how you can manage to keep it at that speed and then just measure the length of the course and you'll have your answer. And it's probably pretty disgustingly low time, probably a minute or something.
And I mentioned that the other day, right? I mean, there is a theoretical best time that, and I wonder what that is, and be nice to sort of achieve that. But no, I'm far from that because the simulator displays you what your current speed is, right? Somewhere on top. And so between all the slowdowns, I mean, I'm cranking the speed up when it's straight, but I do always slow down when I realize, okay,
Right.
I'm getting a little off the line. So I'm always slowing down a bit. Still, my average speed is pretty decent, but the average speed is nowhere near, right, the maximum speed.
Well, you were doing pretty good to get that 20 seconds on that, that first intersection or whatever it was.
Yeah, but now I'm stuck. So that's not doing any good if I'm
really,
stuck now.
But you just have a few problems to solve because really, once you get, I guess if you can get the notch, situation figured out, and that is the worst notch in my opinion. And then I guess the sine waves, that's another thing to figure out. But I guess although it does it slow, the original dumb controller does a pretty nice job, but it's slow. So yeah, I don't know what to tell you.
Yeah, the sine waves I think I can handle. I mean, the one in D2 is handling it quite nicely, right? Because it's the thicker lines. And so that one it's doing it well. So if I know it's I'm facing that, I can slow it down and it'll probably do it fine without the judge objecting.
Right.
So that leaves me really with the gap in E2 and the gate. Although the gate, I think the gate I'm gonna be able to handle a little easier than the gap. I mean, the gate is fine, I think.
Yeah, I'm with you on the E3 though, because the robot I did in the real world, the trouble that I noticed is that just like you said, at the point of that white angle, the distance, the thickness of the black from the point to the white tile in D3, the
Mhm.
thickness of the black is about as thick as one black line. So you've got to discriminate the white line from that space, which can look a lot like a black line. And
Yeah, exactly. Things like that can happen, and I've been taking a bunch of screenshots, and so I can look at them sort of offline and look at this. I can tell, yeah, it's picked up the wrong thing and treats it as the center of the line. So I have a couple of these screenshots, and I know I got to improve that logic so that my overall accuracy in detecting the center of the line needs to go up in some of these situations. So that's what I'm trying to do.
yeah,
Something that's been helpful to me is in cases like that. I think what I've ended up doing, not looking at my code, so I've probably forgotten what I've done, but I have been back into it now. But often I have a couple different sensors, and I think I'm going to add a few more. And sometimes I say to myself, well, this sensor is seeing a clean, single intersection type situation. This sensor is more of a mess. So I'm going to pick the cleaner one and, use that as my current guide, so to speak. And I think that's worked pretty well. I think that's what's getting me through most everything. But my problem now is I'm going back and thinking about, what happens when the thing does, if you're trying to run like at a fast speed, your turns happen gradually as the rotation rate accelerates. It's like a spiral. And my current goal is I want to understand how to spiral into a turn so I can drive fast into a lot of those turns. Now, one thing Will suggested, and I'd be happy to share the code, he suggested that really if whatever's guiding your line following, let's say you've got a sensor that's 3 inches in front of you, it really is helpful to have cookie crumbs dropped from that point and not from the center of the robot. And it's amazing, that view I think is going to be pretty helpful. And I just wrote that today. What I did is I just harvested the cookie crumb code out of the library, since I'm not allowed to mess with the library anymore. I copied that out and I added a little bit of code that would compute, and I still need to test it probably a little bit, maybe another day or half day. But anyway, it allows you to plot in red cookie crumbs the position of your sensor, and you manually say, like, okay, in my case it's about 4 inches, I think, or 3 in front of my center of my robot. So it's like a line of code there to specify that in your controller. Hey, I want a cookie crumb there being dropped, and then there's another line or two to say draw those new cookie crumbs that are using that code that you end up tacking in as a separate tab in the sketch. So I'd be happy to make that available. And I didn't know exactly if, I suppose I could post that to the GitHub, but I guess I don't want to screw up making any changes to library code.
Not in the master branch, but you could make a dev branch.
Okay, I could do that. All right.
Yeah.
Or people could email me, and I'll just send you the
that too.
That way, I know who's working on this.
I give you a stamp. You can put a floppy disk in the mail.
There you go.
But what are you using those cookie crumbs for?
Well, it helps to really to see what the sensor is doing. And what my problem right now, if I try to run a very fast turn around a circle, where the sensor is that's seeing the line is totally different than where the center of the robot is. So if you look at Chris's, like his first turn there, F, whatever that is, F12, F11, okay, my robot looks similar. It tracks real well. But when you look at where my line sensor is, it's going outside and it's looking a little freaky. Particularly as I speed up, it gets worse. And the interesting thing is that as I push the speeds, the path gets really wild, and I can see why I fail eventually. When I push full speed, I can see, why the thing is failing. And then, then to go to like just the oval course, it's pretty fun. I just got this up and running. But as I drive the oval course, I can see this sort of, strange. Well, I could illustrate it, I guess. I'll let Chris finish, and then I can yak for a minute.
Yeah, no, actually, I didn't have really much to add. So this is where I'm at. But one secret I'll reveal, since you were talking about, what you're doing with the line sensor. One thing that I think is helping my logic in staying on track at high speed is I have a front and a rear line sensor, right? And I'm looking at both, and that kind of tells me not just, in a sense, not just at what angle am I sort of on top of the line, right? But also how far away am I from the line? So it's really, I calculate an error basically as a combination of, well, what does my front facing line sensor tell me, right? How far off I am, and my rear sensor, and I combine that to calculate a number and then a proportional adjustment. And it's all just proportional for me right now. And I haven't tried recently taking that second piece off, but I suspect that it's helping me just make it basically. And I'll have to admit, I mean, my logic is somewhat sensitive, right? If I have sort of a couple parameters that I can tweak with your parameter editor. If I make a small change in the proportional gain, so it is making it right now in all those places except what I highlighted, but I can't claim that it's super robust. If I were to go the other direction, which I use as a robustness test sometimes, last I checked, I don't think it would make it the other way around the course right now. But that's kind of how I look at the robustness of my setup. If I can make it in both directions, then I'm happy.
Actually, Chris, you brought up a point that I thought I was going to make, and I don't know if has been made yet, but it's almost like we had talked maybe last week or the week before about how you could effectively program just this course and just go through this course, and if it got changed even slightly, the robot wouldn't make it. And it almost seems like the challenge, I don't know, it's maybe a bit late to make this suggestion, but the challenge is to be able to go around the course both directions. And I think, I know, we mentioned that the start and stop was the problem, but truly to be able to go either direction on this course would suggest that you're not programming it to the course, you're programming a robot's ability to navigate any course.
We've talked about that, and not just reverse directions on the same course, but any combination of these basic tiles.
Yeah.
And I'm right as of right now. My logic is 99.9% generic, right? I mean, I do have special logic to detect that very acute angle, but I could improve that to detect it in both directions. I could occasionally have a false positive in some other places that look, to the sensor similar. But other than that, again, the other place where I probably have to add special logic, and I'm doing that, right? I'm trying to do that, is this gap. I'm gonna have to treat that gap differently than the rest of the course. You just can't just keep going the way you're going in these other curves, right? So there's gonna have to be some special logic, and but I still think that's not the same as literally programming to the course, right? It's probably gonna end up being something like, all right, I hit an intersection and I'm transitioning into black. You know what? Let's slow down a bit because I don't know what's coming next. It could be something weird. So let me just slow down a bit, and hopefully I get aligned to this little partial line and so on. So, I'm not planning to program it directly to this course, but there might be a teensy element of that, right?
Gold plating.
As an engineer, right, I got to take advantage of the information that's given to me. Otherwise, I'm not doing my job, right? I mean,
constraints. The constraints are the constraints.
Ongoing both ways.
Carl, here's a question then. Is there anything in the rules to the course that says you can't simply program the course? Like you could just say go left, go right, go left, go right, turn, go fast. Is there a rule that keeps people from doing that?
No.
That's a discussion like the PID loop Git discussion. That's
But that may sound, I mean, that's probably harder than it sounds, to be honest, right? Because how are you going to do that? You're going to basically go by time and say, all right, for a fraction of a second, I'm gonna go straight at full speed. All right. Or until I know I'm hitting F12, then I'm gonna sort of step on the brakes and make a turn for a quarter of a second, right? And I mean, you'd end up doing something like that.
It would require really good odometry, and that was consciously disabled in contest mode so that you couldn't do that.
Or you could just use time, right? Because
Mm-hmm.
absent of noise, right, and other things that impact your speed, like battery, right? You could just go on time, and you're going straight. Since that is not currently.
Think about it, right? The cumulative error, unless you have it dead nuts on, I mean, that cumulative error is going to get you. There's no way around it.
So that's what I'm saying.
Yeah,
I don't think it's as easy as it sounds.
I know a way around it.
It's a whole other challenge in a way, right? To do it that way.
The library guy, that's right. Might as well just solve it.
No, and I mean a way without whatever. A way to do it without cheating. I mean, I don't have like little what do you call it, back doors into the library sort of thing.
No, that's on the table.
But in a way, we're already cheating because we have like a curved line sensor with like 50 elements to it, right? I mean, does that sensor exist in the real world?
Well, video camera. I mean, this is what really made me interested in making this simulator. Is the predecessor to this is a 3-dimensional simulator where I have a mock video camera, and it's really a better simulator, not a better one. This is a lot more work's gone into this, but I do have a simulator that puts a camera, above a robot and lights it with a spotlight and has to suffer through bad lighting. But it was more complex to implement that or to share that, but maybe that's next is the video camera thing. But anyway, with my robot, and that simulator is also what I use for my robot code effectively. And in my robot, I use this kind of methodology for studying the video image. I take lines and arcs and so forth, samples off the video image. So I should be able to demonstrate that. Maybe that could be my demo for the contest, even though I have not worked on that. So it's at whatever state it was, but at least it mimics this fairly closely. And if I spend I'm hoping a week or less, I should be able to get that robot ticking pretty well with the using my controller that I've developed on this.
Yeah, I mean, you mentioned camera, right? I mean, I've thought along the lines of just treating this as a camera, right? Compiling almost a bitmap out of multiple line sensors, but I'm too far down the path that I'm on, so right. I'm not sure I want to change direction. I had to catch myself, right? Otherwise, you go down some rabbit hole. I also started Googling TensorFlow. Okay, how would I do this on neural net? I've mentioned that, right? I really want to learn how to solve that kind of problem with machine learning, with a neural net, but I'm not going to make it to the contest. So I have to do that after the contest. But I want to figure that out, right? Because that's, to me, right? I mean, that's should be an easy problem to solve if you know how to, do that sort of thing, right? You have a couple line sensors, whether you get a full bitmap or even just fragments right from the line sensor. You feed that through the neural net magic, and outcomes, well, outcomes either, okay, here's the center of the line, which is what I was thinking. I would probably just have it tell me where's the line, and I decide how fast I drive and how I steer. I don't think I want my neural net to make all the decisions, because that becomes less flexible. But that's what I would really like to do, and I'm going to have to defer that to another time. But it strikes me as one of those classical problems, right, that people solve with neural nets. And I've found YouTube videos where people did line following robots, but they're all actually, in the end, frankly, were very simple, right? I haven't seen any course that comes close to this challenge course, right? And someone tackling it with a neural net, because that neural net is gonna get real confused. I mean, you're gonna probably have to collect so much data, right? So many sample images. The training part is gonna be hard, right? Because you're gonna have to collect the data first. Right, you're gonna have to manually drive the robot.
you'll
take
have
samples.
this classical hard-coded algorithm that you're doing, and you can use that to train the neural net.
Okay.
There
Right.
you
And
go.
in the places where it doesn't make it, I manually steer it. Right?
Well, and if you can run it slow, then that would, or you could just
When you get
whatever,
those,
you could fake it.
No, but you still have to collect ground truth, right? If you to collect data, just collecting the images, yeah, that part's easy. But if your neural net is going to tell you where is the line, you're going to have to first capture in some fashion for this image, where is the line in the image, right? Otherwise, what are you training the neural net with, right? Unless you say you're just training it on the steering decision making, which I think in the end is going to be less flexible. So if you
And that's
want it
what
to tell
Donkey
you where
Code
the
does.
line is, you have to sort of first capture that ground truth, with your manual labor.
Yep. Cool. Well, it was a good rabbit hole. Thanks for taking us down that one. Who has another rabbit hole for us to dig into?
I've got a question that I'm hoping somebody can answer for me. I've got two rhombas that are behaving weird, and Doug Parody seemed to know some information where to go on how to fix them. They're the 530 series, and the batteries are good. I've got, I can load them down with a power resistor and draw like an amp and a half out of each battery, and they hold their voltage drops a little bit, but for the most part it's above 14 volts. And so I'm looking for somebody that's played around with rhombas before. Anybody out there that can help me out?
No,
Anybody?
no experience.
No experience. Okay.
What do you want to do with it?
I
Right.
want to fix. There are two 530 series rhombas that one, you turn it on, it seems to go good for maybe 20 or 30 seconds, and then there's not the main light, but there's a little side light that comes on, a little red light, and it just stops. And you can push the button again, restart it, it'll go again for 20, 30 seconds, and then a little red light will come on again and it'll stop. And the batteries
So
are good.
battery issue? Hey, the batteries are good, but I wonder if they're dropping out. Do you think that's possible?
What do you mean dropping out?
Well, I mean, I wonder if the voltage is dropping at some point. I'm just guessing, that's
Yeah,
things act weird.
I can
And
load it
also,
down. Yeah, I looked at it with a meter. I didn't look at it with a scope, but yeah, I drew like an amp and a half out of each battery for several minutes, and it seemed fine. So I'm not certain.
I don't know about the electronics, of course, on the inside of that, but it might be some kind of a fail-safe that if something's wrong, like there's a direct short or something like that, that maybe it just does an auto shut off. And so to me, it seems like there's either a logic shut off because there's something wrong, or power shut off.
Maybe too much friction in the motors is somewhere, right? And then something's overheating, or there's some overcurrent, and then some self-resetting fuse kicks in, something along those lines.
That's what I would think.
Yeah.
So-
Yeah.
It's
So,
letting
the
you know.
hope was so you didn't want to hijack it, because a couple years back that was the thing you would do with them, that you would actually have the little port that you could plug in, basically take over the thing. So I actually had a book on that about whenever and did it. Yeah, it was
like
several years back.
Discovery series, the first ones, or
Yeah, it was like the first one or the second one.
yeah. I've got two of those too. So the fleet is down to one working robot now. It's out of 4. So it's oh, and that was the other thing. I redid something for my wife. She asked me to do it, and I had an old Samsung phone, and they were unplugged for a little while, and then they got did the work and moved stuff back in the living room. And I don't know if you can see it or not, but it looked
it's
like
bulging.
the phone, serious bulging. It's like 3 times the width that it would normally be.
Danger, danger.
That's called not good.
I think that's like the point at which it explodes, isn't it?
It may be,
That's
yeah.
short of explosion, isn't it?
So put on
it
some
could
goggles,
be.
take it outside on concrete and beat it with a hammer and see what happens.
Yeah.
When wearing
Probably
safety
burn my
goggles.
eyebrows off.
Actually,
I
actually
did
send it to Harold and let him do that.
Okay. that's
Sure,
good.
man. I'll blow it up.
Here, hit this for me, Harold. Yeah, so I've never had that happen with a phone battery before. I know Carl had a pretty high capacity battery that I think it got about as fat as this one is, but it
Yeah.
actually like took the phone apart, like pushed the LCD
Oh
up
yeah,
on the top surface
Isn't
of the screen of the
That-
phone.
that's not good. That's
not
Frankly,
good at all.
Ray, I wouldn't even have that in my hands, honestly. I think I remember reading about these things, and they actually do expand before they explode.
Yeah.
It's
Yeah.
actually quite dangerous, I think.
You know,
I actually brought it
several
back
years
in.
ago,
It's sitting out on the driveway.
several years ago where they banned all the Samsung phones on the air flights because the batteries would catch on fire. But
Yep.
I believe what the problem was is because these batteries are actually flat. In order to get them in their low, small compartment, they fold them on top of one another. And
Oh.
one of the edges was rolled on some of those batteries due to a manufacturing defect, causing a direct short inside of lithium batteries, which when the lithium catches on fire, it's not just like your normal, ooh, I lit a match kind of fire. It's a fire.
Yeah.
It's hot as hell.
It's a thermal runaway with
Yeah.
like 1,200 degrees Fahrenheit or 2,000 degrees burning temperature. So
Yeah.
Whoa.
you're not going to stop it without special, I don't know what is halon or something. You're just not going to stop it. So you need to get that out of your house, man.
I think
Yeah, I was like I said,
And
it's
if-
been sitting out on the driveway for like 2 days. I just wanted to bring it back in to show you guys.
And you want to see what happens, just check YouTube on nail through lithium battery because they have to do special, I got into this because when I worked at Nokia mobile phones, but they have to do special designs of the batteries so that if you get like a nail puncture, it limits the amount of problem. And it's still going to be a problem in a lot of cases, but there's literally, I think there's a nail puncture test in the IEEE specs or something like that.
Oh my God.
Oh, yeah.
Yep. Pretty bizarre.
Which is why we want to get to the solid state lithium as soon as we can, because I think it doesn't have that problem, but.
Yeah. The other thing I've been working on, I was hoping to do a demo today, but I had 2 sets of the motors and I had wired one of them up to the basic micro controller that similar to what Harold's using, and wanted to take that whole setup and put it on the back of the mower. And I had only tapped 2 of the 4 motors, so I could, basically attach the motor frame to a bracket. And when I went to put those other set of motors on, because I hadn't done it, I hadn't touched them in a while, I realized I hadn't tapped the other 2 holes, so it kind of like blew my whole strategy to get it done before sunset. So couldn't make a video, couldn't demo anything. So it's kind of like major disappointment. So, but maybe next time I'll have a video.
That's cool. You'll get there.
Yep. In the meantime, I think I'm going to throw this thing back outside.
That's a good plan.
Good idea.
Yeah, put it this way, we're not allowed to ship those batteries. Like if I go to Adafruit or whatever and buy those batteries, they won't ship them overseas to New Zealand because the normal commercial planes cannot carry them legally.
Oh,
They're too
wow.
dangerous. Yeah, in the passenger compartment or in the luggage compartment of a normal commercial plane, they don't have halon or whatever it is in the shipping parts of a big plane, like the UPS planes, and it's simply too dangerous.
Yeah.
Yeah,
I didn't think
batteries are scary.
they should put it in water, right? It'll still burn underwater. won't it?
Yeah.
Yeah. So, okay.
It's literally burning the water at 2,000 degrees Fahrenheit. It's literally burning everything that comes in contact with it.
Probably.
Burnt water.
It sounds like a video game.
It does. It'd be a cool one. Marie, did you have something or Or are you just working on the side?
Who?
You.
Me?
Right.
Oh, well, I I basically. Does anybody know what an INA 260 is?
Is
It's
that
an
the current thing?
Yeah, it's an an Adafruit
Not a
current
clue.
sensor. And I got a second one in the mail, and I wired it up because I'm basically what I want to do is wire one of them to each of my motors, so I can catch motor current and know if it's stalling. And there's a few other things I wanted to do, so I took the robot apart. And when you take a robot apart, you can't always put it back together again.
Hate that.
So I think I might have fried my Raspberry Pi. So what I'm doing right now is making wires. I'm going to make a longer 6-pin DuPont connector so I can actually plug in I have a spare older Pi, and the Pi that I'm running uses an SSD for the boot sector and an SD card for the boot sector and an SSD, one of these guys, these Samsung 500 gig SSDs for its main drive. So I'm going to basically see if I can boot up that Pi at all. I think I fried a Pi though. I'm not sure how, but yeah. And that just means I got to put another order in and wait a few weeks for it to get shipped to the States. Because if I buy them in New Zealand, they're like $100
Wow.
or something like it's ridiculous amount of money here. So yeah, that's where I'm at. Yeah.
You'll get there.
Stuck with bad hardware. So
That's pretty cool. I'm interested to hear how far you get with the INA 260. I've seen that one because it looks like it's just like a system on a chip, right? It has the built-in shunt and it has an A to D, so you can use an I2C bus and then just measure current at whatever sample rate it can get you. So
yeah, high side or low side. I don't think even a sample rate's much faster than I2C, so it's basically a continuous read.
Yeah.
And it's low side or high side, and so I'm going high side, and that thing can go up to quite a lot of current, up to I can't remember 30 volts or something like that. It's quite a nice little
36 volts. Yeah.
Yeah, 36 volts for $10. So, and there's a little solder patch on it that you can change the I2C address. So you can use multiple of them. So, but I think what happened is you know how when you wire a left and a right motor the same, and you realize when you first turn the robot on, it doesn't go straight, it goes in circles because you've done that thing. I think what I might have done is wired it backwards, but didn't tell the INA 260 I'd done that. And I think I burned out the INA 260 by having it wired backward. I'm not sure about this. Wired backwards. And I think that must have done a spike or something and blew out the Raspberry Pi because the Pi won't boot now. And I've sent a message into the Adafruit forum asking them if you wire the sensor backwards, which is just a resistor, I thought. If you wire it backwards, what would happen? But, oh, Ron, you're off if you're trying to.
I'm just talking to myself. I don't think it should matter as long as the power supply for the current measuring device is correct. Then let's think about that. I don't think I shouldn't get fussy about that. It's an op-amp. It's isn't it like so? It's in this case, is it more than one device? Because I thought the device was originally a TI amplifier that basically would amplify a voltage, a very small voltage near a rail sort of thing. But then they're adding in there another. Oh, here we go. Thank you.
Yeah, it's got a really, really tiny resistor on it. But they do label the pins V plus and V minus. So.
Oh, yeah.
The load. Well.
It kind of looks like it matters.
All the goodness is wired to the 5-volt rail. So I can't believe it's that fussy there.
That V bus is a little pad you solder or don't solder for high or low side. Yeah, so I've sent a message into their forum, and now they want me to send them a photo of my robot, and I thought, that's not going to do any good. If they saw the wires, they would go, So the best I can do is basically tell them that it's just, I actually have started to draw up a graphic of my wiring because the photograph wouldn't be of any help at all.
Well, we feel for you.
Yeah, I'm kind of. I mean, it's kind of frustrating because, as you may know, if you've been following my progress, is I just want the damn thing to run forward. You know, it's like last couple of weeks has just been going kind of downhill step by step, and now I don't even have a full robot.
Well,
Yeah.
at least you haven't burned a house down with the bad batteries, so that's good.
Yeah. Well, and I've been, but you know, the thing is that I've been using these big honking Makita 6 amp hour things with a little can you see the bunny sticker on there? Yeah.
Yeah.
But that's to tell everybody around the house not to use this battery for the rest of like vacuum cleaners and things. But you know, if one of these things go, the whole neighborhood goes. I mean, they're like this is like a nuclear bomb.
Well, so here's a question for you, Murray. Do you at least have like a simple fuse?
Where?
Uh-oh, drawing
Well,
blanks.
actually, these, I'm just being funny because actually these have a fuse. And there's a fuse in the battery itself, and there's a fuse in this clip thing. I don't have a fuse on the robot, no. But
Is it one of the programmable fuses, or is it it's gonna blow kind of fuse?
a blow. I've opened this thing up when I hacked it because I put a regular power connector on it. And
Okay.
there's not much, there's actually a 5-volt power supply in here because there's a USB output there, but I've pulled it out. There wasn't enough room for what I needed and that, and the 5-volt supply isn't very accurate anyway. So this is just a hollow plastic shell now. Actually, you're right. I took the fuse out of here because, well, it wouldn't have been, no, that fuse was only on the 5. No. The fuse was only on the 5-volt.
Hmm.
This is meant to be a clip that fits on the top that gives you a USB 5-volt. I just realized that. So that 5-volt fuse is gone because I'm not using 5-volt anyway. But my understanding is batteries are pretty safe. I mean,
so think about how many amps those batteries can push out at whatever voltage that is, and then just think about all the exposed bare wires that you have in your robot dangling here and there, and Dean's connectors and screwdrivers and screws, and just, I mean, I feel for you, man, but put a fuse in the main power line.
Yeah, it's not a bad idea.
Yeah, give yourself a break.
It's 6 amp hours at 18 volts. You know,
That's
pretty hefty.
You can cause some trouble with that, and because your robot's only going to draw an amp, right, or something like that.
Well, what I'm doing, of course, is the 18 volts goes into the Thunderbolt motor controller, so it goes directly to the motors, but everything else goes through 5-volt regulators, so they're going to blow first. But I'm having a main fuse is not a bad idea, but I don't think that battery is going to go first. The 5-volt power supplies would blow. You know, that normal plastic smoke you get when something goes, you know, that we're all familiar with, I think. Yeah. So
yeah, when that battery bomb goes off.
Well, that's the thing. So, I mean, it should have internal protection so that if it's shorted, it hopefully shouldn't get into that state, right?
Right. But these are power tool batteries. Think about this is used for a power tool, like a real serious power tool.
Yeah.
And like, you know, you basically have a drill that can actually lift you off the ground can be run by these. And so I assume these are safe. And in fact, one of the reasons I chose these batteries over like the regular green cell batteries is exactly safety. That I get a lot of power out of these, but they have a commercial charger that works for these. And when I clip that on, there's no short circuit possibility even. And so actually it was for safety that I chose these. Because I don't trust those little green cells. I always think those are kind of scary.
I made the same decision, Murray. We talked about this a couple of times, but
oh yeah, that's right.
Exact decision. I use an Aerobi, you know, but still doesn't matter. It's a whole package, it's a whole system. I don't have to mess with it. And just messing with this stuff, and you get crossways with a few too many currents. You get things a little too hot, you get a slag. You get a robot that's a flame.
Yeah. Well, and actually, that's a good point when you're designing a robot like Doug D and people who are starting. You know, one of the very first things I had to think about was what I was going to use for power supply. Was I going to use like, you know, rechargeable batteries, nickel cadmiums, you know, what kind of batteries and how much power do you need? And like, I've got another second robot that I've kind of got in the works design wise, and I haven't quite figured what I want to use for power because Like, I think I mentioned that it must be 6 months ago. I bought a little robot and then was paid back by the dad, a little robot for one of our local 9-year-old girls. And that robot requires, I think it's 4 of those quite hefty priced green cell lithium polymer or lithium ion. I think they're lithium ion batteries, and a $50 or $60 charger in New Zealand for that. So it was like $100 and some odd for the batteries and the charger in New Zealand. So it was quite a substantial amount of money. And that charger is a pretty safe charger. But, you know, having a 9-year-old girl with 4 batteries that are explosive and a fancy charger, I almost thought, well, you know, that's not what I would choose for myself. It's what goes with that robot. But part of the reason that I went with these big power supply, you know, this power tool batteries, is that I figured they were safe, because I'm not going to be loading them anywhere near as much as a power drill.
Well, so you've got good battery safety, but so I had batteries like that. They were NiCad, about the same size, used them on hedge trimmers. But I had them hooked up to my little RC plane battery charger and such through some custom cables that I made. And I was just fine until one time I got kind of careless. And I mean, the batteries, NiCads don't catch on fire like lithium's quite the same way, but that's okay, because the problem wasn't that. The problem was that they had so much energy that even with the 16 gauge wire or something, the 16 gauge wire got really hot. So as soon as I realized there was a problem, I went to grab the wire to disconnect it. But the wire was like a heating element, right? So I really burned my fingers.
Wow.
And if I would have, so it was after that I put a fuse in, and now life is much happier, right?
Well, and Carl, actually, I'll take your advice. When I get next to our local electronics store, I would think an inline fuse doesn't sound like a bad idea at all.
Actually, I can show you. I found Amazon. Now that I think about it, I found these. They're not that expensive, and they're really handy, and they're cheap, and they're. And I seem to have lost it, but they're. Oh yeah, so if I can find it, I'll put the link in the chat here.
Well, one of the modifications I made in the last few days to the robot while I was rewiring for these INA 260s was actually the main connector between the plug that goes from the battery into the robot was a solder connection, and I cut that, and when I put it back together again, I put it together with those standard 1/4-inch spade connectors. So now actually sticking a fuse between 2 spade connectors would be really easy. So I've kind of ready to go with a fuse. So that's, you know, just basically wire up an inline fuse, won't be hard at all.
Here, look at this. This was an awesome kit. $13, and you get 10 of these fuses and a whole bunch of different sizes, and the connectors too. Yes.
Wow. That's what I need.
That is, I mean, and they're a good size too. They're really convenient. They're just perfect for robot size and robot power and voltage.
So what about a self-resetting fuse? Would that have any advantages here or disadvantages?
I did some research, and okay, I'm not an expert on that part of the power system, but to my understanding, the self-resetting fuses, if you look at the specs, they are not intended for this use case.
Oh,
So
really?
their ability to stop current goes down every time they stop current. So they stop working. They are a bad idea for the way we're using it. This is
Really?
a much safer, much better idea. Absolutely.
Well, they have both slow and fast circuit. They're called, you know, are we talking slow fuse, resettable fuses, or circuit breaker?
Here, I ordered some as well, but
Thermistors, right? You're talking about a non-linear resistor type
the
fuse.
poly fuses. These.
Yeah,
Oh.
yeah.
These things right here. So yeah, because this was
They get hot.
this was the thing that was in the DPRG Club robot. But these things, if you go read the data sheet and the intended use, when we try and use these to protect our robot, I mean, it's the wrong way to use them.
Yeah.
It's a bad
I'm
idea.
not disagreeing with that. I was just thinking you're talking about circuit breakers. Why not just use a circuit breaker?
Usually they're pretty big.
Well, no.
Yeah.
You can get really tiny circuit breakers. They're about that big. I mean, they're not small, but I think I've seen some really tiny circuit breakers, like, you know, 5 amp ones.
Yeah, I know
But
they
yeah,
used
maybe
to
the
use
use is the easy one. I mean, you don't really, except
well,
that I have to take the robot apart to change him. That would be a pain.
yeah. I know the like on the ramps boards, they used to use those polyfuses, and the later revisions of them, they went back to it's like an automotive style fuse, like a blade fuse,
Yeah, like
kind
the
of like
spades.
like the ones
And
Yeah.
you can get these in minis, but the thing I found was that
Well, but-
these were more expensive than that other one I showed you, the inline.
But if you
Mhm.
operate below their trip current most of the time, right, where they're not getting hot, then they're not going to be in peril. And it's nice if you screw up and you drop you short a couple of wires. Sure, they get hot, but they can tolerate that, can't they, Carl? I guess I should read the specs. I've
I'm-
used them successfully in a lot of projects, but anyway.
I'm sorry, I forget the details. All I know is that when I went to build up the hover sim thing, I looked closer at it and decided that I would be much more comfortable using these. I forget the exact reason.
Hmm.
kind of a
But it-
traditional fuse. Yeah.
It had to do with it had to do with how they were. I think the trip point might have changed. I don't remember exactly, but it's a good homework for somebody that's interested. Come
Yeah,
present to us.
The
Actually, in
only
terms
battery
of-
I ever had actually explode was a battery in my truck. I went out one day to start it, and it literally blew the top off the battery, and scared the shit out of me. I tell you, I was thinking, the Godfather movie or something. He goes out and starts his car.
And you go home that night and there's a horse head on your pillow.
That's right. But yeah, Walmart battery. So,
Hmm. Well, I think if I think about it, underneath my robot, there probably is plenty of room underneath for a circuit breaker where you can get access to the button. And that's probably what I should do. I mean, you're right. A small short that doesn't blow anything, or let's say a motor, backing up or whatever, big deal. But a true short on an 18-volt battery, don't want that. No.
yeah. If you have a plastic frame robot, you could probably use that wire to cut your robot in half, or just melt right through it.
Yeah.
Okay, who we got here?
Topic that I've been considering for my robot is that I'd like to have, how a cell phone, you can set it on the charger and you don't have to disconnect the battery, it just charges it. And so I'd like my robot to be able to roll up to a charger and just charge it without having to disconnect things. And that looks more complicated than you think. If anybody had any experience in that?
Well, if you're using a Raspberry Pi, I'm not sure about Arduinos, but there's a bunch of those things from many companies for a Raspberry Pi, and they basically, you have like a USB connector and you have your lithium polymer or lithium ion battery, and it just plugs right onto the Raspberry Pi and allows you to do exactly what you're talking about. There probably are those for Arduinos as well, but they're basically just a thing where if there's power coming in from a source, it'll go into the battery and charge it. It's just an automatic circuit. In fact, I don't know where I've got it, but there's, what are they called? There's that one company that makes batteries for both Arduinos and Pis that it's like a uninterrupted power supply. Basically, I've got one. I don't use it, but it's basically a little battery that fits on top of the like a shield on a Pi. And if there's power, it'll power up the Pi and charge the battery. And then if you unplug the power, it'll just keep running. I think it's called Pi. Is it Piborg? I'll have to look it up.
Yeah, I forget the one you're talking about, Marie.
Pi Juice. That's what it is.
So that's the one way. Pi. Yeah, there you go. The Pi Juice hat.
Yep. Are you on an Arduino or a Pi, Doug?
I'm going to have both.
Oh, okay.
So
Well, this works really well, and there's a whole bunch of software that goes with it for management. It's basically like an uninterruptible power supply for a Pi. And I have one of those. I had to actually get it shipped from a company in China because they wouldn't ship it from Canada because, of course, the battery can't come legally through the mail.
Right.
But from China, no problem, of course.
Good to know. Good to know. I've been thinking of this fancy using a servo to switch between two groups of batteries so I could charge one while the other one was keeping things up. Maybe this is easier.
Well, this company also puts together a whole bunch of solar panels for the same purpose. So you could basically put a Pi out on the field somewhere with a solar panel and have it running, let's say, with a radio connection or something for, if you're doing monitoring or something like that of your fields or whatever. So there's quite a lot of stuff out there in that area.
Yeah,
No, I wasn't sure what you were asking, Doug, because these circuits, they're meant to go between the battery and a charging system. So if you find the right kinds of these, then you can. I think you can make it to. If your goal is to be able to charge the battery without pulling it from the robot.
Yes.
So you need some kind of energy management charging circuit system like this. And what they have in here are the kind of hardware fail-safe pieces in there that make sure that the input voltage is of the right range and that it doesn't attempt to charge the battery over full, because trying to fill a lithium up past whatever it is, 4.2, is a bad thing. That's a bad thing. Yeah, as is discharging them below whatever 2.7 or 3 volts. Those are both bad things. But these circuits made to do, and then like these are built into your phone basically, or in some cases it might even be built, like in laptop battery, bigger things, it might be built into the battery itself. So the Makita thing that he has might even have this kind of logic circuit in there in the battery itself to protect and isolate the battery from the outside world.
Yeah, that TP
Good to know.
4056 commonly used
then-
for that.
So what, Ray?
The TP 4050, I think it's the TP 4056. That one integrated circuit that's used a lot for
Yeah,
charging.
I actually bought some TP 4056s because I thought that might be my solution. I just hadn't done anything with them yet.
Yeah, I haven't looked too closely at these. There's another thing too. So one of the club members, or sometimes club member, he's used the Adafruit wireless charging stuff.
Oh, yeah.
Yeah, I've looked at that too a little bit. Back up close to something and let it do its deal.
Yeah, so you can buy these, and then you can, there you go. You can make it compatible with the standard Qi charging system.
The only thing with those is that, as anything electromagnetic, the power is exponentially goes down as distance. So you have to have the two coils extremely close to each other. So you'd have to have like a docking station where the actual coil on your robot was like within millimeters to get a good charge.
Right.
Well,
My long-term intention is to have one or more docking stations around the house and have the robot sense when battery's getting low and go over to the docking station. And
Doug, you realize though that your robot is so loud that any burglar would run if they heard that thing going cha 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 cha.
My big problem now is my dog attacks it every time I run it.
It's pretty loud.
Yeah.
You might go for a stealth motor, really.
Well, I'm going with what's in there right now, but this is just my I want to say practice robot because Harold's not watching, but he was nice enough to give me this robot, so I'm going to make it autonomous and make it around, and it's going to be a functional. Hey, yeah, I'm going to make it work because that was what I promised when he gave it to me.
No, it's you're making use of it where I was not doing anything. It was just kind of whatever. So whatever you do with it is perfectly 100% okay because you've done more with it in the past month or so than I've done with it in 20 years. So, I figure you're winning. You've got that. So, yeah.
Well, if you get over to my robot blogs, you'll see definition of my HARP project, and that's what it's going to be. It'll be the first one of those before I do the real one, which maybe will have better motors.
Yeah, one of the Rhombas that I have, somebody actually brought to Robot Builders Night Out. Just asked if somebody wanted it, and being the junk collector that I am, I said, yeah, I'll take it. Anyway, it sounded like maybe they tried to vacuum a beach with it or something. It's incredibly noisy. And I've cleaned it out, and yeah, there's grit in the little gearbox that runs the two brushes. But I think it's done some damage, because there's another one that's just like it, and it's much quieter. So maybe that's what's going on with your robot. The gears are just chewed up or something.
Well, they're plastic gears and they're old, so I'm sure that they've got some issues there.
Yeah, the little toy motors that like the ride-on toys, those are incredibly noisy too. I think they're all spur gears, and they're probably not molded that well, and plus you get a little dirt and grit in it.
Well, back in the 80s, they were just happy if the thing would roll around. They weren't worried about noise, I think.
Noise, yeah, probably not.
Well, that kind of reminds me there. I think, let's see now, I've got almost all my robot hardware, like the frame and the motors and everything, from this Canadian company called OSEP. And I was looking around for photographs of the OSEP motor so I could send it off to Adafruit forum or whatever. And I found that there's a guy, I think working for OSEP, has posted a blog entry about the robot that they put together that looks really cool. And it's a differential drive and all that. And I started looking at it, and it's like it's two wheels, and then it's got a caster, but the caster's like so far forward that the thing actually has the caster probably like maybe twice as far as you would think if that was the radius. Like it's way out in front, and it turns out the caster's in the front of the robot, not the back. It's a rear wheel drive.
It's a
And so the
canard.
guy reviewed it, and it's like this really cool robot, and it sounds completely non-functional. Like you could run on a smooth floor, but you couldn't go over any bump. You couldn't go onto a low pile carpet or anything like that. And I just wonder how many robots are out there that just sound kind of cool, and they've got nice design and all that, but when you go to actually use them, they would be completely non-functional.
Well, I have that problem with Roby here because his caster's in the front, and that's a problem. I mean, it bumps that caster up against something. He doesn't want to go. I tried to run the body around, but the body doesn't fit on it in the other direction unless I build. See these screw things here? They're not spaced correctly for, I don't want things to fall out, but they're not spaced correctly for the body to fit on it the other way. So I've thought about building something across there that I can then put the screw holes in a different place, and that would solve the problem, because on the base here, you've got this little caster, and then you've got the four wheels are all power wheels. The two can go forward or backwards. And anytime this caster hits something going forward, it stops it dead. But with these wheels to pull it over, it'll climb all over stuff.
Well, I know aesthetically it would look kind of bad, but what if you just put all the sensors on the back of the robot and ran it backwards?
Well, I've thought about that, but he's facing, I mean, you got this nice looking little robot here.
Yeah.
Backwards all the time. So this fits on there real nice. It just won't screw on backwards. But I can change where the screw holes are, and I think I probably will eventually do that, just because, like you say, that caster going forward, it gets stopped dead on almost anything.
Yeah. So speaking of that, part of my problem, my robot, my rear caster was just you could, if you're watching me how I'm rolling this thing, I couldn't roll this. I couldn't roll that way. This is actually pretty smooth because I went and got a new one, a bigger one, and this is really smooth and it's not crunchy at all. The one that came with the robot chassis is like kirk, 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 kirk. It's like there's I'm rolling on gravel or something. And so I went to Harbor Freight, found one of these for like $1.50, I think it was $2 something, and then while I was there, I said, well, let's get some more options. And so I got a couple other smoothie options, and I've got some really tall wheels for my front coming in that'll help me. Either this one's a little larger, a little taller, same kind of thing. And then if I got, this is the other different ones they had. This is the one I'm really liking a lot, just because I like the look. And every one of these things is very, very smooth all the way around in which way it turns and where it goes. And sometime I think Thursday or Friday, my big wheels will come in from Servo City, and we get to start 3D. This tail dragger is going to be outside the radius because of the height and things I got to fill in, but I'm going to just do a 3D printed part on that, so I get the height right, so it's all nice and level, and we'll just hang this thing off the back of the robot. And
Home Depot has those too.
Yeah, I just hadn't had a chance to go. I will go over there and look at those as well. I just hadn't had a chance to go over there like I had the Harbor Freight one. But
actually, Harold, that particular one you just had in your hand is, I think, the same as the one I have, or maybe the smaller version. But I think we talked about this maybe last week or the week before, is that what I did is I took that, drilled out the actual frame, kept the frame and the rotary part, but put one of my matching robot wheels on there. So it's basically the same frame as you've got, but the wheel that matches my robot. And that way you end up with the same basic wheel. You know, you've got two wheels for your differential drive, and then your caster has the same wheel style.
Yeah, because these things are literally just pop riveted on. Thing. Certainly drill them out and then do whatever you want to with them.
Yeah, because mine's running on a bearing, so it's really good.
Yeah, nice and smooth. And of course, all of these are rated at like 90 or 100 pounds worth of force. Like I'm never going to put that much stuff on one of these things, but if it'll support that, my few pounds of robot should be no big deal as far as smoothness and all that stuff goes. Shouldn't get bound up. I say shouldn't. You know,
coulda, shoulda, woulda.
We know better.
Yeah.
Okay, let's see. So, Mr. John, what's going on in your world?
Oh, nothing much. I did get parts. So eventually, hopefully, I'll get that thing put together. So I went over to Micro Center and got some little lures.
Look at that.
So we're slowly getting there.
Yeah.
So that's about it.
Cool. All right. Hey, Mr. Jean, how about you?
Hey, yeah, I'd like to share my progress on the PID.
Since Saturday?
My original goal. Let me try present with my multiple screen on. If it fails, I'll log back in and try again. But yeah, I'll try without disconnecting all these screens.
Is it like looking up a telephone number on your cell phone while you're in the middle of a call?
Can you see my screen?
Yeah.
Let's see if you can.
Yeah,
Can you see my screen?
Yep.
Nice. All right. Okay. Yeah. Otherwise, every time I have to So okay. So let me tell you what I started off to do. I have my little motor set up, and initially I want to put the feedback on my wheels, right? So I did wire these things up. I have a Mega 2560, and these wirings I'll have to rewire these at some point. But I'm glad I have these wirings. Everything works. You know, if I drive, let me show you my UI. This is, hopefully it's not too small, but basically I'm gonna connect it, and I'll have my messages coming back. Right now I'm monitoring the memory, task running time, and my feedback signal. So if I enable feedback, I mean, this line is like, I can enable it. I can put a reference, put the gain in there. I'll put a fire again. If I set it, so you can see my signals, the reference, and the feedback basically works. And I can select both channels so that both of these wheels are running. And okay, I want to show you guys this. So if I'll stop this. Stop this. So right now I'm logging these in in the file. But also initially it's like not initialized, and then it's running, and then I stopped it. Next, I'm gonna put it in a window. I'm gonna try to put it in a window so I can put a PI again, put a step in there, see the response. But as of now, I'm not there yet. But anyway, so my goal is to really figure out. I mean, I feel comfortable that I can tune the PID gain and see the response. And when I put a wheel on there, to feel how it's working to the way that I feel it is somewhat optimized. Yeah, I do want to share with you one more thing here. So when I'm doing the encoder, I find one thing. Have you guys used let me see. It's something called port read registers, like port read registers, like a fast way of reading registers. So it's something like this. Like a register is pine.
Yeah, I mean, what that basically is, it's just accessing the memory mapped, register directly rather than going through the standard Arduino API, right? So this is it's just regular C code, right? And I can't quite read it, but that register variable, that's a pointer. Nah, I can't see all the characters. It's so small.
Let me see if I can make it larger here.
But yeah, that's pretty typical, way of directly accessing your hardware, from C or C++. You are reading the register, which is really just a memory location.
Because my pin is changing for different channels, so I put it as a variable. The port, I would like to use it. So last time, I think Chris, you were mentioning these serial reading is using interrupt, and what I find is when I put these things in there, the digital read, and I have too many serial writing there, it will. I think it's blocking the interrupt. Like it's too busy when I'm running this 1 million baud rate. I don't know if there's a good way of reading this fast, but probably, I think it's too much optimization I'm dealing with. But I'm curious about this port reading, how I can change it as a variable, like I'm doing this port read, but I can tell it to read different channels for different.
So what usually happens is the different ports on the Arduino, right? It's A, B, C, D, or something on the Mega. I forget, maybe E. Each port gives you 8 pins, and depending on what version of Arduino you're using, some or all of those 8 pins are exposed, and they all have their certain functions. And when you sort of, unless you're sort of talking to the A to D controller, if a given pin is just configured for either, as an input or an output. In your case, as an input, if you read the port, let's say port B, right, you get an 8-bit integer, and those 8 bits, in the byte represent the 8 pins of port B for the most part. Again, some pins sometimes have special functions. Now, if you're just trying to read one pin or the other, what you end up having to do usually is you read in all 8, and then you just use regular C code, right, to mask out the pins you actually care about.
Isn't there instructions to do that in one instruction? It's been about 10 years since I've done.
Right. If you, in
ADR
assembly,
stuff.
you're right. If you were doing this in assembly, you'd be actually using that instruction. You're absolutely
But
right.
sometimes there's macros. I know GCC had macros where you could say, if port C bit whatever 3 is set. I mean, it would just literally it would create the single instruction for that for you, sort of thing. I mean, I guess it takes an instruction or two to get it into a variable or something like that. But I just seem to remember there was way back there was very efficient ways of.
I mean, definitely, if you want to cut down on even a couple instruction cycles, that's the route you'd want to go. But I see a lot of code there in this interrupt handler, right? There's a ton of stuff that's going on there that's taking up a lot of time, and you may want to measure how much time you spend in there.
Yeah. Okay. I was thinking, well, I want to take advantage of the plot, but this is defined, and I have this is 2 pin for my one motor. I have another 2 pin for another motor, and I just find it hard to manage it the way that I have now, which is I have these 2 variables. So it's a little difficult.
Yeah, you might. I'm trying to remember. I'm trying to remember if I've done that recently on an Arduino type thing, but I think there are libraries out there that give you highly optimized encoder reading code. And in fact, even I think Polaloo has one. Yeah, actually, I think maybe it's on the Romy. Yeah, I know someone else mentioned one, and I think I've seen Polaloo has one probably for the Romy platform. Where they're directly reading it through interrupts. But one thing they're doing there, which you may not have to do on an Arduino Mega because you've got plenty of pins, but if you find yourself running out of interrupt capable pins, there are some certain hacks you can do there. So you just use a combination of one interrupt combined with one other regular GPIO. Again, just in case you're running out of interrupt pins, but that's probably not your problem. But the point is, there are libraries out there that do this for you, that you may be able to just use almost as is, and it's going to be reasonably optimal sort of C code, reading the pins in the most efficient manner possible, etc.
I see. To call their memory to read the pin values. Yeah. Okay. Cool.
Read or digital write, like to whatever, maybe light up an LED or something. Those actually take several microseconds to.
Oh, that's bad.
If you access port registers directly, it may be like 1 or 2 microseconds. So much faster.
Yeah. I think when I reuse this 1 mega, 1 million baud rate, like you guys are saying, I'm probably each interrupt is like 10 microsecond rate. So I think I have this constant 10 microsecond when I'm transferring data full speed. 10 microsecond, something runs, and when I interrupt this is what I'm guessing, because before I add this, I was able to use that 1 million baud rate and everything works fine. Now my fast motor will block my my Arduino. Basically, it just stops. And that's
so
when I run
your communication stops when the motor is running?
Yeah, when my motor runs at full speed. Well, I mean, when the fast
Ah,
motor
oh,
runs
okay.
at full speed.
Yeah, so you
Because-
have all these interrupts coming in on your encoder, and then the interrupts that need to get processed for the serial communication. You're going to miss some of those, and then everything falls apart.
Do you need, I didn't pay attention. Are you doing quadrature, or are you doing just something less than that, like one interrupt and then sample? That was the typical way I handled high
Right
speed.
now, I am I have 2 motors and I have 4 interrupts. So I am planning to drop one of the interrupt, like 1 interrupt per motor. That's what I'm planning to do.
Yeah, because the
Yeah.
typical thing I would do is I would have 1 interrupt on one line, and then I would pull the other one, and that would cut down, so I wouldn't have quadrature, but I'm pretty sure I would have both edges. I might have had doublature, so I might have had half of the potential resolution, and that worked for my case because it was a motor that was geared fairly low but had like a 500 count encoder. That's what I use on my balancing robot. It's like a 500 count on a Pitman motor, but I did that way back with Arduino or Mega, not Arduino. It was Mega that whatever I custom created way back before Arduino, or when Arduino was in its infancy. Which, by the way, I have 1,000 of those 20 2560 touchscreen boards, and well, it's a combination. I have 500 not touchscreen and 500 touchscreen, so I have a lot of those puppies floating around. Anyway, for very low cost.
One thing I'm curious to ask you guys, the two interrupts, say 1 motor gives you 2 pins, right? And those 2 interrupts gives opposite direction. So, I mean, this is basically the way I calculate position, based on the 2 pin. Based on the 2 pin, like an exclusive OR type of operation. But I have to put in the direction to make the 2 the same way of adding or minusing. Do you guys? I mean,
So
I
in
don't
other words,
understand
you
So
have to
why.
again,
change
the
the edge. You're
libraries,
looking at
the
the different
libraries that are
edges.
out there, they'll have all this logic implemented for you. I mean, you don't have,
Oh, okay. Okay, yeah, it's just curious. Okay. Yeah. Yeah, so the next step, I am still curious because one of my interrupt misses, one of the motor misses interrupt, but I realize it doesn't really matter for my purpose of control, because if it misses 1 interrupt out of 1,000, it doesn't really matter. But I'm gonna basically, when I have feedback on, I realize when it's running variable speed, the position tends to drift apart. So I'm gonna go back when I have good control here. I'm gonna come back and see if I can correct the encoder reading so that make it perfect. like if anything misses, I know why, and I can correct them. Probably not necessary again for the purpose of controlling speed, but just
let me
interesting.
just because we were talking about, let me just share real briefly what I was
I'll
mentioning
stop sharing here.
with existing libraries. I don't know, I hope you can see this tab here. This is the Pololu. You can see the URL, I think, on top there, the Pololu, one of their libraries, or their main library, the Pololu AVR, for anything that has an Atmel on it. And they have a wheel encoder library, and here's the C++ code for it. And you can see here in this roughly 30 lines here, that's the interrupt. And it from what I can tell, and I haven't studied this carefully, it handles for 2 motors, right? So a total of 4 pins. And you can see here, it's not a lot of code, right? They're looking at the pin values, again, for both encoders, motor 1, motor 2, A and B. Each one has 2 quadrature signals. And then, the way you get direction is you have to kind of memory memorize the last value that you've seen, and then they do a little bit of logic here, right? And then you end up with a +1 or -1, right? That's what you get. You either increment it by 1 count or you decrement, where nothing has changed, right? And that's it. You know, this is the interrupt. It's probably about as efficient as it can be, right, for dealing with two motors here and counting those signals.
The benefit of using this library, I mean, in terms of reading speed, the pin, this digital pin reading speed, is this faster?
Well, yeah. So they're using this function is input pin high. So I'm assuming that they've done that in a fairly efficient manner. Again, I haven't looked at this whole library, but I know from experience with their libraries, they have often created their own functions that they use instead of the standard Arduino functions, in situations like this. So again, you'd have to look at the code that I'm highlighting here. How is this implemented? I'm not sure where it is exactly. I guess it's in some other module, but I guarantee you, it's the reason they're calling this function and not a standard Arduino library function is because this is much faster.
Be nice to see it'd be nice to see the assembly code that's generated when you compile the. Is there any way to get a listing?
Oh, from his or from the Pololu one?
Yeah. Well, I guess from that, is there a way to get a listing of the instructions generated?
Well, the short answer is yes. I mean, I haven't. Again, in the past, I've used pieces of that library. I don't have one handy, but yeah, when it gets built, or if you build it from scratch, you can tell the compiler to not delete it. Yeah, to produce a listing.
Okay.
So before I think Dave was mentioning about having the 2-pin and generate the position. So the way you showed, it needs to remember the old state.
Yeah, it does. I'm pretty sure.
I think
I'm pretty sure you need to know the state, because if you just look at the pins, you can't determine if it's going backward or forward.
You don't need to. So so it's really just 2-pin, like at the switching edge. Well, David is here, so it's good. I mean, it's really an exclusive OR.
Show that. Okay, where? There we go.
Why don't you just?
I don't know. Do you see my Arduino?
Not yet.
Code there? No.
You have to share it.
Well, okay. Let me try again.
Share screen magic.
It's like I have to really understand it to know it. Before I was like, oh, what does it mean? No, yeah.
Cancel.
There's no need to remember the previous.
No. Okay.
Like a quadrature code?
First of all, you don't have to remember the pins. All you have to do is do an exclusive OR.
Right.
Now, how do I do this?
Or in the rising edge of one, and the other. And if one state, if it's the other state, it's very simple.
Oh, okay. There we go. Now I see what the problem is.
Yeah, so I think if you have the edge information rather than just the pin state, that might be the trick.
Right. It's just like
Now it's showing.
And I think on that Arduino, that library didn't have the edge information that we were looking at.
Yeah.
Well, so when the interrupt occurs,
okay, I don't know.
Can't you set, like, for example, can't you set interrupt on rising and falling, and then when the interrupt occurs, go ahead and sample the pin?
Yeah, but then you don't.
Then you know whether it was a rise or a fall, because the interrupt occurs, presumably not another interrupt has happened.
Yeah.
So you just sample the pin at that point, and then oh yeah, it must have been rising because the pin's high, or it must have been falling and pin's low. And then if you want, sample the other channel And if you only want doubleture instead of quadrature, you got it. And you can do that in about just a couple instructions. I'm going to dig up some code I've got from 10 years ago.
Clearly, I'm not showing what I thought.
Oh, you are.
No, we just saw it. We just saw it.
I see it.
Yeah, you
Oh, we can see your screen fine, Dave.
Exclusive OR.
Yeah, it is.
Put it back. You just removed it now.
No, now it's not there. Yeah, it's good.
Take off the highlighting.
That's an exclusive OR right there.
Yeah.
That's
Take
all.
off the highlighting.
The exclusive
And that's
OR.
a pin change interrupt you've set up here.
Yeah. So it's the interrupt is set up for any change on the one pin, and when you do that, you read both pins and you do the exclusive OR.
Yeah.
And you either increment or decrement depending upon whether the exclusive OR is true or false.
There you go. That's pretty.
But you're getting interrupts on the other pin also?
No,
Yeah.
I mean it's any interrupt would work.
One pin, and then you look at the exclusive OR.
No, but if you don't get interrupts on the second pin, then you're not getting the full full set of pulses.
Doubleture.
You don't have to have the. Okay, you get only
You get half the
on
pulses.
Yeah, you gotta have pulses because you don't have that many pins you can do interrupts on. You only got 2 pins to do interrupts. So
Well, you
do
can
one-
do pin change.
do
You
one-
can do a pin change interrupt.
Yeah, it's a change interrupt.
Yeah. And
Okay, but yeah, if you set that up, then you're good. You'll catch all 4 edges, right?
No, because you're only sensitive to one pin.
But you could make it sensitive to both and then query it.
But he has 2 motors, right? You have a total of 4 signals coming in.
But you could
And
do
you'll-
pin change interrupts on all those.
No, you only have 2 interrupt lines on the Uno.
No, well, don't you have the ability to do what's called a pin change interrupt on a AVR? I think so.
Yes.
So you can set up a bunch of pins that will.
Oh
interrupt.
yeah, okay.
And then you
Yeah,
have to,
I
you
know.
have to figure
You're right,
it
you're
out.
right.
Decode
You're
what
right.
pin it is.
Yeah, you have to query it. You have to ask what the state of but that doesn't take any time. Yeah,
Well-
it takes a fraction of a microsecond.
Yeah,
Well, if you're using native code or a macro instead of these funky little functions that take 10 instructions.
yes, exactly.
So apparently you can do it in 2 lines of code. There you go.
yeah.
So I don't know
Better-
what Polo
better
was
library.
thinking, doing it in 30 lines of code.
So like I say, use the exclusive OR and you're there.
And now I know it works because I logged the data and it makes sense. So yeah, I mean initially I was looking at sample code which remembers previous state, and I just remember David was like, "There's the exclusive OR. What does it mean?" So yeah, good.
Well, that little carrot right there is an exclusive OR. And if it's a 1, you increment, and if it's a 0, you decrement. And that's it.
David, do you know why my 2 encoder, the 2 pin direction is opposite? The 2 line.
Well, the reason why they're the opposite of each other, because one is on the right-hand side and going one way, and the other's on the other side going the other way.
This was that trick that I learned a little while ago. If you run them both in the same direction, your robot spins.
Yeah.
Right. Your motors are
One encoder is going to be, going opposite direction.
backwards.
I mean, it's 1 rotation, but how come it's 2 directions?
What do you mean?
I mean, I'm using 1 motor.
Well,
It's just
this is for 2 motors.
yeah, right. Yeah, when I use 1 motor, I hook up the 2 output, two interrupt pins, and those position decrease opposite direction. I mean,
Well-
changes opposite direction.
That's why one encoder is doing a minus and one is doing a plus. with the exclusive oars. Because one's going frontwards, one's right-handed and the other one's left-handed.
See, this sounds like the discussion that I learned back at TI from the control loop wizard. And it really bothered me because I was doing the circuitry and he was doing the higher level algorithm, the control loop for this stabilization system. And I said, look, I want to get the polarities straight all the way through. And he said, don't even bother to try because your chance of getting the polarity right is 50-50. Just wire it up. And if it works, you got the polarity right. If it's wrong, flip the polarity.
I think
that was the official control loop designer of the system. Yeah.
Yeah, in fact, in my Python code for my encoder, I've actually got a Boolean for both the encoder and the motor for my left and my right because I didn't even want to try. I just flip those bits until it works.
Well, that's why, I wired it up and I said, oh, I got to put minus instead of a plus.
Yeah. Now maybe the A and B is opposite.
No, so that's why I'm showing the animation, Jan, right? Because the reason you get an A and B is so that you get more resolution and you get direction, right?
Yeah.
Yeah, they're phase shifted 90 degrees.
One thing that David pointed out a while back, which was interesting to note, is that motors don't run the same speed in either direction. That motors run better in one than another. So if you have two motors, they won't
absolutely right.
Yeah.
How do you define the positive direction? Is this like a positive voltage gives the positive direction? Because right now my two motor is opposite. I have to put a minus sign in the feedback.
Yeah, of course.
Yeah, look at the diagram. You can see right there. I mean, you just from the the edges and what the state of the B channel is relative to the A channel, that tells you direction.
Yeah, exactly.
Yeah. And the direction is probably arbitrary. Whoever called out the specs for that motor probably said, okay, if you apply positive voltage to this terminal, it should spin clockwise. So.
It works great until the next copy comes over from China where the board was put on backwards, like happened on my robot. Two of the motors were wired one way, one motor was wired the other way, and it drove me nutty. Even more nutty, I should say.
Yes, it's good. It's only two direction. So if one doesn't work, change the other way.
Yeah, that was a cool find, Chris. Thanks. I put it in Slack for everybody.
Well, the good news on my end is my cable that I made. I've just done a test, and I didn't actually blow my Pi up. It turns out that my SD card got corrupted probably when the power went off. So I've got to do a reboot on a refill on this card. So the Pi's fine.
Excellent.
Yeah.
Good karma. All righty. So let's see. Harold, did we hit you yet?
Actually, Donna.
Or Donna. Yeah, Donna's there. See, we had a discussion with Donna on Saturday, and then I did want to share an update because DPRG board, we met last night. So we have an update about contests and such. And Donna has a cool update too, because they'll have a contest in January in Seattle.
Hearing from Donna.
I think she stepped away for a moment.
Yeah, I think their contest was they were going to ship a whole bunch of robots to a location and run them or something.
Yeah, so we're doing the virtual. So okay, so December 12th. Here's the lineup. December 12th, we agreed to have two contests. One, of course, is the line following, thanks to Ron Grant Extraordinaire, virtual line following, and the other will be a freestyle open style. And the way that'll go is that we'll accept a video, say 2 to 4 minutes, which includes 15 seconds, minute long pitch of this is why my robot's so cool. You should vote for it. So we'll have a way for everyone on the contest web share to watch the video, and at the end of that, vote for the robot you think is the best.
and we'll have little guidance out there and such. I just got to get it posted. So we'll have those 2 contests on December 12th. And then I guess January 16th, Seattle Robotics Society will host a hybrid where they'll accept mail-in or drop-off if you're in Seattle, mini sumo robots. So I guess they have a lot of success in Seattle with these mini sumo, a lot of popularity. So so that'll come up on the 16th of January. And then looking down the road, there's a couple things coming up for DPRG. So way out in, say, June or July, we're hoping by that time that there'll be at least enough comfort that we can meet in person outside. So we're looking to have a physical outdoors Robo Columbus kind of thing. And unfortunately, I don't know what we can do for remote folk unless you want to mail your robot or something, but that's what we're looking to do to get back in the physical world is June or July. So those are the 3 contests. And Donna, you're back. So I was just explaining our calendar a little bit, including Seattle in the January timeframe. But was there anything you wanted to mention?
No, not directly. I'm sorry, Carl. I had to get my dog outside.
Oh, no worries. Yeah.
So I'm sorry. Would you mind repeating what you said about your contests and what the plans are, and then the
Sure.
Seattle bit?
Yeah, so December 12th, we'll have the 2 contests, freestyle, send in a video, everybody votes, and the virtual line following. I just got to get that posted. We got to get some rules written up and decide on prizes. But aside from that, we're all ready. And then January 16th is the contest you're hosting.
Correct. Yep.
I mentioned that. We haven't reached out to the 1 or 2 guys that are in the mini sumo yet in our club, but hopefully you can hear from them. And anyhow, I intend to, at least, I hope everyone else on the call thinks about it, but at least participating to observe. I think that'd be cool.
I did
See how it
write,
goes.
excuse me, I did write Scott Gibson, but I didn't get a reply from him. I should double check his email, but I did write him anyway.
Oh, cool. And then in June or July, Donna, we're gonna hopefully be comfortable enough to meet together outside and do a Robo Columbus in a park somewhere.
Okay. Would you maybe be entertaining thoughts of supporting external, farther away clubs like from Seattle, as far as doing a virtual portion with that as well?
Yeah, if you're up for it, I think we ought to entertain that idea. Why not? For sure. Because that was another thing we talked about last night was even if, let's say it's 2 or 3 quarters, like middle of next year, before we can even really be comfortable getting a group together in the makerspace, there seems to be a lot of popularity from Northeast and Northwest, LA, so we in New Zealand. Well, so we don't want to lose that. So we were thinking about what could we do to have the best of both worlds, right? To encourage the wide geography by virtual, but in person as well. So
Yep. Okay.
So we were talking about ideas like having a core time in the meeting where we would have the virtual big screen in the room, and whoever wanted to log in could log in, and then we could have people there in the room, and we'd do what we're doing now, but those of us in the space would be doing it physically, and whoever wanted to join in remotely, we would just arrange that. And then for people that had physical things in the room, we'd have a camera, and you could watch the robot in the room. And
yeah, sounds good.
That's one idea. The other was to alternate weeks, but I think it's so far out. We're just kicking ideas around so far.
Yeah. Well, and then who knows what's going to happen with this COVID, lockdown situation anyway. For
right.
Even that short of time frame out.
6. Yeah, I mean, if it goes as well as Dr. Fauci was hinting at, then it sounds like the vaccines might be getting their way into the general public by the 2nd and 3rd quarter of next year. But that's still far from being able to really relax the masking and distancing things. So
Right.
And
Yeah.
do they make telepresence robots that look like a Segway, you know, that are kind of all terrain or?
you would think I mean, we're a robot club. Why don't we build one, right? So
Yeah. You know, you could have people from all over wandering around in a telepresence frame, you know.
we could get Doug to put a camera on that thing in his background there from Harold. It'd be great.
There will be a camera on that robot at some point, and it probably will qualify as telepresence.
There you go.
Oh, yeah.
Wasn't there that weird thing back in the early 2000s called Second Life or something like that?
Second
Oh,
Remember that?
did that ever go away? Isn't that Fortnite now? Or
if anybody's still hanging around on there, they'd be sad. Well, we could all join.
Steve Rainwater, I think, took a tour recently and published a little bit of stuff that he looked at some of those things. He said that Second Life is no longer quite so weird. I remember one of our members was like a red elephant. I played with it for a few days, and but now it's not like weirdness. People are more kind of normal, which is sort of boring. I think I like the idea of, you know, glowing fields of plasma and different weird animals.
I think the problem is that some people were making body modifications that were a bit on the untoward side.
Yeah, I see. I was going to get into it, and a friend was telling me that people do all kinds of crazy things and do anything they want. Like this one guy made an island that had trees that were in the shapes of male anatomy, and I'm like, you know, I don't need that. I just don't need it. And every tree on the island was that way. I'm like, no, don't need it. Just don't.
And so on the SRS side, Carl, when you guys get your formalities, you know, online for what you're going to do on December 12th, maybe you could send me an email or send an email over on your mailing list service, and then once that I see that email, then I'll go ahead and you know, do an advertising email over on the SRS side to you know, remind everyone about what's coming for December 12th for you guys. Okay.
Cool. Thank you. Yeah. Okay. We'll put on the meetup too. So whichever way works.
Okay.
They'll both be available.
Mm-hmm. Okay.
Well, I spoke too soon. My Raspberry Pi is dead.
So I take
live and dead again.
Well, it sounds to me like, Murray, since you've got a dead pie, sounds to me like you've automatically got dessert for tonight. You know, just cut that pie up into wedges, and you've got dessert.
Yeah, well.
Yeah, there you go.
Oh well.
Oh well.
Take a few weeks. I've actually got the old pie. It's a B+ as well. It's an older model of it. I'll just put that in the robot, but that'll be my interim. God. As I think somebody said, every time they make an order, they buy two. It's like, yeah, well, yeah.
All righty. Let's see. Who have we? Ron, did we touch you?
No.
Oh man. You're up.
I could show off a little bit of stuff. Okay, let's look at. I haven't done too much, but let's see if I can find this. Oh, I will do some looking. I didn't find my stuff that does, well, what I call doubleture on the Arduino, but and I should find out what this generates in the way of instructions, but this is code from way back. Let's see, no, there's no date. Okay. Anyway, but this is Arduino code. And in my case, I had surplus resolution on my encoders, but you can see this, I bet you this instruction generates,
are you
or this
sharing
macro.
screen?
Oh, I'm
no?
not. There we go. There we go. Let's try this. Is that better?
Yep.
Okay.
Yep.
Anyway, this is code that I used on a Mega, probably 2560 or Mega, maybe even a Mega 32. Who knows? Anyway, all about the same. But this was just what I call, a singulature. It did a one interrupt that I set up here on one edge, and then sample. And this macro right here, if bit is set, that generates like one or two instructions. But by next week, I'll find, I'll get the GCC compiler up or AVR Studio, so I can actually get a code listing of what gets generated here. But in this case, this was a pretty efficient, albeit not taking advantage of the full resolution of the quadrature outputs. But for me, it was important because I had a situation where I didn't want to suck up time with my encoders. So I reduced the resolution of my motor encoders in trade for lots of time spared in overhead. And believe me, these generate, in this case, this is a long, so that's 2 or 3 instructions. But I think this is about 1 or 2. So these interrupts execute very fast and they don't use any registers. So you're talking, microsecond or something like that, or a couple microseconds. But I'll try to research this because this is stuff I have not touched in 10 years. Easy.
I have a question about this time. I was reading this, like digital read takes a few microseconds.
Oh, that's terrible.
Then if you're talking about per interrupt, is this like the clock cycle?
Oh, say again?
Yeah. So, I mean, if it's 16 megahertz.
Yeah,
then one interrupt is like.
Well, no, it depends on the instruction, right? Some instructions are single clock cycles, some are multiple clock cycles. So I put a link in there because one of the club members, Dale Wheat, wrote a book, Arduino Internals, and he talked about this, and he talked about literally mapping the Arduino routines down and then figuring out how many clock cycles they take versus just doing the correct assembly level register reads and writes. And then even special tricks like he was calling out some of the Arduino instruction codes where if you would read from the register, it would flip the bit or something like that. So you could do a read and a flip all in one operation. I don't know.
Okay,
he had some crazy stuff in there. But I think, Ron, it looks like your code is getting that same level of granularity there with your like int4 vector and things. So
yeah, anyway, blah, blah, blah. Okay, I'll do a little more research on that. But that's right, Dale may have gone crazy with that. I remember my early getting into this was being worried about creating like, video timing and stuff like that. So I was like obsessed with single, knowing how many cycles something took and so forth. And of course, interrupts are not efficient when you start talking about sucking up time on something that's very, very critical. But in this case, it wasn't. I just wanted to. But no, anyway, let me push that aside, and maybe I'll be useful or maybe not. So I'll get rid of that. Anyway, I've been playing around. Now I'm getting a chance to play with writing controllers, and I just wanted to show you this. I thought it was kind of interesting in that. It's a demonstration of the fact that I'd only solved the acute angle in one direction, but my code is good enough that it'll work in the other. I'll show you this. Hang on, let's see if we can speed this up a little bit. Oh, so the new cookie crumb trail is Will's suggestion. So notice the double twist there, and my code's gonna fail on this right angle right there. Boom. But anyway, I'm about to fix that. But anyway, what you're seeing is the red trail is really the sensor, which I use this line sensor right here for my line following. And Will's suggestion was rather than drop cookie crumbs at the center of the robot, why not drop them where you're actually reading the sensor? So that's what motivated me to create that other set of cookie crumbs. And that's what I'm right now. Just kind of hacked some code together to do that so that I could put it in the sketch without touching the library. But I'd be happy to make that available if you think it would be useful. I also created this little I'll just start back over again and slow down a bit. A little chart recorder, but it's really crude. I'm charting the velocity as it speeds up, and like the red line in this case is the turn rate. And so I can watch my turn rate track and also my speed ramp up and ramp down. And I think that might be handy, although I don't know, maybe it's just fluff. But, oh, and you can see my, also the error is the third term, and that I don't have scaled correctly. And the error is, in this case, the line tracking error, which is essentially the distance of the line from the center of the sensor or whatever. So anyway, but for what it's worth.
Maybe, I don't know if we need to require the error to be less than certain distance to say it's totally off the chart or something.
Yeah.
You know, I mean, it's not in the off the chart good, but like totally off the chart.
But if you look at the center of the robot, look at how well it's tracking. So really, what we're talking about here that I'm plotting is not the center of the robot, and that's kind of what. So if I would draw that plot, you'd be, well, look at the green crumbs. You know, they look good, and isn't that what I think what we're talking about? But the thing about having a line sensor far out in front of the robot, and Will pointed this out, is the further you get out there, as you turn your robot, you have this great ability to change the error in where your sensor is. So in other words, right here, let me get the robot back over here. Let's see, it wants to get away from me. Let me just stop it. Anyway, so let's say right here, as I turn the robot, if you notice, if we had our sensor in close to the center of the robot, turning it wouldn't do anything to the line error, the line tracking error. In other words, the robot's over here, and I rotate the robot, this distance right here from the center to the line isn't changing. But as Will points out, the further out here you get, rotation in the robot changes your line tracking error. So you don't even have to be moving in theory to correct that. You know, now that, of course, obviously turning doesn't move this robot over to the line, but it is an interesting idea. And that's why these red lines look like such garbage, you know, as we run this thing versus the center of the robot.
Is it, is it at the acute angle? Is it spinning around its axis once? Is that allowed?
You can do whatever you want, I think.
No, well, okay. Well, no, because we have occasionally this debate about how closely you have to follow the line, right? So if you lose the line and you do a 360. I mean, is
what's
that
wrong
okay?
with that?
I don't know.
I don't know. To debate it. Now, in this case, I'm going to write the 10 lines of code to fix that. But I just was sort of, you know, I thought, oh yeah, in fact, that's why I created this course. But then I remembered I could just run the real, the actual course backwards. In other words, I thought I'd fix this where it, let's see. So in other words, really, let's see, how do we clear this? Oh, I can't, wait a sec. I have to start it over. Okay, so if we run it this way, you notice, okay, it did okay, but really all you need to do is come over here and I can add a marker. Whoops, let's see. Well,
you're going pretty fast now. I think you're catching up to me.
Yeah, but let's see. Okay, here, I'll set a marker by this and we'll see how quickly I can get there. You'll notice that I'm not there. Okay, hang on, let's see. So time warp, go. That's not a very fast time warp. But anyway, I think I get there in about 25 seconds or something. Yeah, something like that. Whoops, I meant to say go to marker. Here, wait a minute, let's speed it up. Maybe not that fast. Yeah, okay, so 25 seconds. Okay. So you're still beating me, Chris. Anyway, but you watch. I'm just getting warmed up. Anyway, but yeah, the cool thing is to test this. Okay, so here, I think I'll probably do my twirl. Wait a minute, well, I guess I better point the robot the right way. set a marker. Okay, now I can say go to marker, I think. Yeah, okay, so I did my twirl. I could slow it down. Let's see. Yeah, so you can see it did the twirl there. Anyway, okay, but I'm gonna add the code so that it can do the acute angle without doing it. Although I like the twirl. In fact, David Anderson would probably appreciate that. A pirouette, I think you would call that.
Yes.
Anyway, so much for that. I think that's my everything I've got. But yeah, so if you, yes.
You mentioning this sensor can be further ahead. Is there a limit, the offset, the amount of offset the sensor can be?
Well, by definition of the contest, well, as I think we're stating it, is you can't, you got to stick with the simulation without changing the, I don't know if we set it, but we should probably, without changing the resolution. So as it goes right now, you can only get about 6 inches out from your robot. So this area is roughly 12.5 inches by 12.5 inches. And oh, one thing to note is courses, if we look at other courses, you'll notice that the robot isn't scaled properly on this. So in other words, notice how this robot looks very tiny, but everything else is. The lines are scaled properly. The stuff that counts is, but this icon is not scaled to this course, but because this course is scaled to fill this area of the screen. Consequently, just to note that if you happen to play with some of the other courses. Oh, this is what I was going to show you though. Let's see. Let me think. Let's see. Here we go. Okay, so here's a test. And this is interesting because the robot's doing a pretty good job of following the line. But as Will pointed out, hey, by plotting where the sensor is, and this is just about where it's fallen apart. So in other words, the robot's doing good, but the problem is, let me slow it down, the sensor is not. So in other words, you know, and that's what counts, and because that's where this robot's going to fall apart. If you notice, if I get up here, where that
sensor's running out of range.
Yeah, the sensor's getting out of range. And watch, as we'll go back here and I'll speed this thing up. Let's see, we'll restart it. I did write a thing here to test. All this button does is it automates some things, so I don't have to waste you guys' time while I set up time and loop and all this. Okay, so anyway, so let's watch this as I try to speed it up. So 24 inches a second, I'd like to go to max 36. Whoops, it falls apart. But I think the reason it's fallen apart is because why my sensor's getting too far out of range. And, you know, yeah, maybe if I could tighten it up, but I'm having difficulty, you know, as I, you know, alter my PID parameters. Whoops, it's almost making it, but it's unstable part of the time, sort of thing. So that's kind of what's motivating me now to think, gee, what does it take to do a 36 inches per second velocity and roll into that turn? And that's what I'm going to be playing with if I've got any time before this contest. Because, you know, that way I can run this stupid thing full speed. But where I was really was 4 inches a second. That's what got me through the course, you know, at 5 minutes, just right on the edge of being disqualified.
So you want to
But
drift
anyway.
your robot, huh?
What's that?
You want to do drifting, you know, like your wheels are constantly spinning or slipping, and
Right. Well,
control rate maybe.
but by definition of the simulator, and that's something interesting to play with, is literally just set up on your controller. You know, you could set up a forward velocity of 36 inches and then a rotational rate of 720 degrees a second. Those are the simulator maximums, and you'll see, you know, the resulting. I don't know if I've got a setup for that. Wait a minute. No, I guess I don't. Okay, I thought I had a setup to draw a sample circle, but it doesn't take much to do that. And that gets you a feel for what's possible with the simulator. And in theory, and it may not be quite real world practical, you can drive the robot at 36 inches a second with a turning radius of just a few inches. And anyway, so it's interesting to set those maximums and see what they look like. But the problem is to get yourself into a turn like that, you can't get there instantly. So your turning radius kind of spirals in. And it's fun to set those things up and then run them. So you just write a couple lines of code and play with it without having to write, a lot of really complicated code. So let's see if I had, just to show you kind of where I was playing with.
My actual robot may be able to do a tenth of that.
Oh yeah, so here was my turn test. Oh, and so what I got interested in, and it took me a while, somehow this stuff, to think about all the stuff they tried to teach me in school, which was a million years ago, but I sort of have to painfully work out, I think, to believe what I'm doing, but trying to figure out, like, what does it take to do a radius, a turning radius at a given speed. And I guess it'd be nice, I could publish a few of these things. But, here's an example of calculating a turn rate given a speed and a radius. And so the thing is, though, if you say I want to go 36 inches a second and I want a turning radius of 1 inch, it's going to exceed the simulator. So, and it'll complain, it'll say, nope, not going to do it. Anyway, not to yak on, but that's that. Any questions or anything?
I think Chris wants to use that for his maximum theoretical possible speed test.
Yeah, I know. That's what I figured Chris was up to when he said he could do half the thing in 20 seconds. And I thought, you know what? This guy's just setting it full bore, and he's just figuring out how the hell he can turn this robot and get it through the course. So
and, I have to
disgusting.
admit, I had to run a couple experiments on the acute angle. I set up a test where I wanted to find out, how can I get the turning radius? I had to play around with, okay, I have to slam on the brake basically, then turn full tilt, but not for too long, right? Not until I see the line, because then I'm going to overshoot like crazy.
Right,
So I had to sort of say, okay, well, I think I'm at the acute angle, slam on the brakes, turn hard, and then stop turning, and the inertia is gonna, sort of make it keep going. So you have to play around with it a little bit to make a tight turn like that at high speed.
Right. Well, I think fair enough, on the acute angle, if the rule is, as long as you haven't lost the line, then why not radius off that acute angle? My thought is I would like to have a knob where I can just adjust it so that if some judge is going to be fussy, wherever he is, Doug Parody, anyway, I could just turn the knob and relax it to what do you want? Do you want a 1/2 inch radius, or can I have like a 4-inch radius in that acute angle? Because then you might not have to slow down. But anyway, blah, blah.
So did I just hear that this contest now has a subtitle to it? Contest, line following robot contest or Knives Out? I'm just asking that,
What do you mean? It's turning nasty here?
I'm just saying, just
did I say something?
Casual observer,
Oh, it started.
Little friendly
by the way,
collegiate
Ron,
competition. It started with mittens and we've gotten to knives. That's awesome.
By the way, Ron, I took a screenshot. Now I know how your sensors are arranged.
Oh, that's fine. I know. Actually, it's all changing, and I added a couple of but I'll tell you, I like my little half circles, but the lines are creeping in. Since you mentioned the thing about needing to rotate the line sensor, I thought, oh yeah, and I think you even said 90 degrees. No, that's something that, looking at the 90-degree bend, certainly a line sensor on the side of the field of view could be quite handy, particularly if you want to if you want to start your turn early and radius that sucker off. If you're gonna slow down if you want to stop when you run out of or when you see it turn to the right and you want to just run to that intersection and you're going to come to a complete stop, you don't have a problem. But I noticed when I want to keep hauling buggy, then I want to certainly want to see that turn as early as possible. So
I'm surprised no one's mentioned how silent I've been, but okay.
Oh, why you been so quiet, Carl?
As soon as saying all that thing with the knives out thing, I am fully on board. I am fully on board with trash talking to be an element of the competition. Don't get me wrong about that.
Are there trash talk points on this?
Yes.
Plus or minus.
My garbage pickup is tomorrow.
Harold, is your last name Kardashian or something?
No. I'm just saying we have these every year we go to Vegas and we have these competitions in amongst our company, and I am probably an average level of competitive type person. And I told this to some friends of mine or some other coworkers, and like, really? Like, you're pretty competitive. You're pretty there. You're not like, yeah, I'm an average level. I'm not we got crazy competitive people and improving. And basically, if you're not, interpreting the rules, doing a little trash talk, taking your spin on the rules, you're probably not playing the game. I'm just saying.
Yeah, I think Scott Gibson's the master of that. Mr. Trash talk.
Yeah, I wondered where Scott is, because I heard that he was playing with this line following simulator, but we haven't heard anything out of him.
Yeah,
I'm worried about that because he'll
just
just show up out of the blue.
Yeah.
One day he'll come in and
Wipe us all.
Yeah.
He's watching all these recordings, getting all the censored talk, and
Yeah. Doesn't even want to waste time. Just probably fast forwards. Probably sits us, at 200 or 2x on the YouTube, and we're just and he's just listening. Okay, that's important. Anyway, well, he needs to send his mini sumo. I did try to hype it up, Don. I said something like, I hope you'll do it. It's like sending a robot to Mars, and I'll watch, and all this.
Well, hopefully he'll send something over.
Yeah, hopefully he will. He does have, but I guess I do need to check that I sent it to the right email address. I didn't get a bounce though, so he's probably got it. He's just not saying anything. He's playing silent.
I'll get you.
Yeah.
Harold, did we get you?
Yeah, pretty much. I don't have a whole lot of. I've been mucking around. I can show you what I'm in the course of building on. It ain't a robot though. Uh-oh.
The eyes, the googly eyes.
Yeah, I've got the googly eyes, and I'm almost finished going around here. I'll show up my screen right fast. And so I decided to do a couple of things, and I've already printed out the base just because I wanted to get a feel for a couple of things on it. And of course, you always get to measure things a couple of times and print out a couple of things. So I got a bit of a joystick here that's got a clicker on it. I've got an arcade button, and if you're looking at my screen I got going on there, I turn on the mask and I'll turn on my joystick, and that's what I've been playing with about where they're going to go. And I'm going to throw a Raspberry Pi back behind here and destroy my Magic 8 box.
Oh.
Make it so.
Yeah, see, Magic 8 box even wants to be destroyed. And put that speaker in behind this thing. So it's all like you can come up and play with the eyes a little bit. If you push in, it'll blink at you. And when you hit the top of the button, it'll say something to you. And so my friend my friend Michael Perry and I was just bragging. I got one of these things, by the way. Let me put it back up in the transition mode. One of these things in the mail. Ooh.
Is that a
Ooh.
chocolate bar?
What now?
Is that a chocolate bar?
Ah, it's a
Welcome
Wonka
ticket.
bar. The Wonka bar. Basically, this, and I've just pulled it out of the box for the first time. This is a machine learning compute stick on the edge. So the idea is, if we can get it out of here. Oh, come on.
Got the Movidius on board.
Yeah, basically it's like the NVIDIA on board. Basically, this is supposed to process TensorFlow and models and that sort of thing on the thing. So he thought, well, maybe you could hook this up with a little camera on this, and as people would walk by, it could say stuff. Because it's a Raspberry Pi, it'll be internet connected, it'll be doing all those things, running Python. And so while I'm waiting on wheels and other things, parts for the robot, I've had a lot of this just waiting in the wings and just waiting to do something. And so I've just been playing with it and adding things to it. And that's about all I really have. And I've just had a lot of parts laying around. So I'm like, well, let's make use out of them. And I thought it'd be just kind of neat and a neat looking thing. I'm going to get
the Intel Neural Compute Stick?
Yeah.
Okay. Yeah. 2, I guess.
The two version of it.
Yeah.
I think it's been out a couple of years or something, or a year and a half. Anyway, Hackster IO says, hey, you want one of these? Sign up. If you win we're giving them away free. You want one? Sure. And it showed up in the mail after a little while. I took the one. I don't know. I went on Amazon and looked. I guess they're like $70, $80 pop. So that ought to be pretty decent for doing something fun. What the heck? And so,
are you going to do one of these?
One of what's? Hold on.
It's 1, 2, 3, 4, 5. I think it can take six of those little six.
Damn.
Oh, yeah, I've been reading on and off because I just got this the other day, and it said a day and a half ago or so, 2 days, something like that. And in between work and other things, I've been reading on this, and the difference between the first neural compute stick and this neural compute stick is that you can gang them up. I mean, you can throw a bunch of them together and they can be set to work in tandem, apparently.
Do a little parallel.
Yeah.
I mean, look at that.
We'll just see what, I'll just plug it in and play with it and see what happens. Probably stream on it. Hey, look at this cool thing. I don't know what it does. Here, let's go stream some. Let's run some demo stuff. Let's hopefully not let the smoke out of it, that kind of thing.
Pretty cool.
And so that's also with this mass thing, along with the stream, there's ways that I can have programs listen to my text chat in the stream. So I can have people have access to stuff. So if I've got a couple of subscribers now, I'm making a whole $4.82 a month. I'm just, millions here coming rolling in. And one of the things and one of the perks is that I can give them the ability to then have other commands. And I thought one of those commands would be cool if I set up a signal R kind of thing. So because I'm running Linux on my Raspberry Pi here, and it's already got text-to-speech capabilities. And with the speaker coming out of the mouth, I figured I'd give people, subscribers, the ability to send in a bit of a phrase or whatever, and robotic talk to me or something. I don't know, and stream me actually building that, because people seem to like that kind of stuff. So, and I kind of like doing it. So what the hell? That's about all I got right now on the thing. I did get some more wheels, some more of the got them from Servo City, and they're the Actobotic heavy duty wheels. They're more akin to what Murray was showing me, and more akin to what you want to call really smooth, heavy duty things that you would put on. They look like the little wheels that come on wheelchairs where you can't push yourself, but you look like those kind of wheels is what they're kind of looking like. And I got some hubs to interface with them. And so while I'm waiting on that, I'm doing this other stuff and having a good time with it. So that's about all. That's about all really I got. I mean,
that's cool.
Yeah, I'm playing with it, and I'm having a good time. Now I'm a little worried because that pop should have just popped right off of there. Here, when it doesn't come off, get a little more force on it. There you go.
No, don't do it. Don't do it. You know what's going to happen.
Oh, it just needed a little extra love. All right, there you go. It's off of there now. I imagine here's what I really imagine happened. Intel is still a sponsor of Hackster.io. I imagine they had about, I don't know, cases and cases of these things laying around because they were supposed to do something with them, and they didn't have enough people get signed up for it to give them away, and they don't have any other avenue to give them away. And since they are a couple of years old, these sticks, if they were brand new, I'd have a different opinion. But since they've been laying around the warehouse for a couple of years, they probably wanted to give some away, but they just couldn't give them to people. They had the people wanted to ask them for them. And so I'm like, okay, I can handle that. And that's actually kind of cool. This whole blue thing here is a heat sink.
Yeah.
Yeah, because it's got holes going through it. It just doesn't look cool. It's actually functional.
Yeah. And it's pretty low power to begin with, if I remember right. Those Movidius chips, they're really, compared to prior neural net chips, those are under 5 watts, I think, and they can do video, like 1080p video at 60 hertz, 60 frames a second.
Yeah.
Under 5 watts and 5 volts, so pretty wild.
Yeah. Pi Image Search had a thing with OpenVino.
Yeah, that's exactly what you got to use to do this. That's exactly
Right.
what you use to this, right?
Yeah. So you want to, he's got very good examples and stuff. If you just look at Pi Image Search, PY Image Search. And
Oh.
Yeah. So he's got an example of how to do it. And it actually worked pretty good. I tried it some time ago, but as far as recognizing, whatever was in I forget which model that was, but there's like kind of a random collection of things you find around your house,
They've got a thing up there called the zoo, and that something, it's some letters in front of it. It ends in the word zoo. And because I was looking at the example of it, and it looks like a collection of random things you may have around the house that then they just call it a zoo, as like a menagerie of stuff, right?
Yeah.
So I'm like, okay, I will play with that and see what happens. And my first attempt on that, I think, is going to be on the Linux box. I've got a Raspberry Pi 4 on my Donkey Car that's currently not Donkey Carring, and so it's hooked up, it's ready to go. Plenty of juice, sort of horsepower, and plug the camera in there. Not a big deal. We'll see what kind of things are going to go and play on that thing.
Yeah.
It could be.
So
fun.
is the idea with multiple sticks, are you talking about like if you wanted to recognize objects or animals, each stick could recognize maybe a half a dozen things, and then you'd have 10 sticks, and therefore you could recognize more things more rapidly?
I don't know if it's that way where each stick could have its own model, or each stick is a parallel on one model. I don't know if I'm sure each stick can have its own model, but just from what I was reading, again, I read for 37.5 seconds, so I could be wrong about this. But I think you're right. Every stick can have its own model. And so one stick will recognize these sorts of things and that sort of thing. But I also think, because the way they were reading, when I was reading, that you can have, like, say, 6 sticks working on one model. So they'll parallelize the task of working on it. I think it might be possible to do that. I don't know that I'm ever going to get 6 sticks ever, because this is free and I'm kind of a cheap bastard. So, you know how that works, right? So,
And do you have a problem that requires it?
yeah, until I have a problem that requires it. And or if a couple, like Ron might have gotten him one or signed up, or somebody else I know, like, well, I'm not doing anything with it. Okay, well, then now I've got 2 of them that I can play with. But very much like Carl and I with our Pocket Pros, whenever that comes out, we got to get together and see if we can get a 4-trace oscilloscope working on our phones through Bluetooth or whatever it is, man. That's what can happen. You saw the latest note, right? We're looking at March.
March, April. It's just patience. It's a waiting game. I'm sorry I hooked you into that, but
no. Don't be sorry. Don't be sorry. I will tell you, thanks to me having to go plow around a few things, I did find my Saley knockoff Logic Pro Logic analyzer. that
Yeah.
I probably should get fired up and make sure it works. So and try again to make sure it does things. I got lots and lots of jumper cables now that I didn't have before. Make sure it happens. Yeah.
Well, cool.
And I will tell you the other thing is I'm about to get off here because I had to go. I picked it up yesterday, and I was waiting for the wife to get home. And the wife got home from her stuff, and I told her I wouldn't open it till I got in, so we set it up. Black Friday deal. I don't normally do Black Friday deals, but especially on Black Friday, but because they're all spreading them out, some of these Black Friday deals are going to be lasting till the 1st of January, by the way, depending on what the deal is. This, however, is not because it's sold out. Walmart every week has a new set of Black Friday deals that are coming out, right? And I saw this and I got on it at 6 o'clock Central Time, which is 7 o'clock Eastern Standard Time, and got me a 55-inch TV, 4K TV for $148. Yeah, see?
In 20 seconds.
In 20 seconds.
Was it a Samsung or an LG?
It's a TCL. That
TCL,
the lower end. It's I don't know where it fits in the scale of things because ONN is Walmart's brand, and I think this was equivalent to that ONN brand.
Yeah.
But heck, if I get it, if it looks good for me, fine. If it lasts a couple of years, I'm probably ahead of the game on that deal, right?
Yeah.
Just all there is to it. And I was down a TV anyway because the way I had a TV for several years, and one of them just a couple months ago blew up. So, this is pretty good timing on that whole deal.
There you go.
Yeah. So it's still 100. The thing is, one of my team members goes, "That's cheaper than the light bar I would stick on behind it to make my."
Yeah, to light it up.
Like, okay. And I picked it up. I pulled up to Walmart, and they've got a special area for picking this thing up, which is over by the garden area. And I pulled it up, and I said, I'm in stall 50 in a white car, and go. Little person walked out of there carrying my TV and said, "Hey, you want this in the back or what?" "Oh, how about in the back?" I'm, okay, there we go. It was all done. Took them 2 or 3 days to get it all arranged.
That's pretty funny,
So now isn't the deal with those TVs? Wait a minute. I'm on. Okay. Isn't the deal with the TVs that somebody's making a couple $100 on the information they gain from what you watch and so forth? Is that why they're so cheap? Is that what we're told? Is that real?
I don't know on that, but that TV itself will not get hooked to the internet because I've got my Apple TV I'm going to plug into it, so I don't really care.
Yeah. Okay. So you use it as a monitor.
I've been Apple's been pimping me for years, so I guess I'm good with that. Even though, I wish they wouldn't, but it is data, and that's what really sells these days. I mean, it's evident with all the Facebooks and Twitters and all the other kind of stuff that's going on. That's in the news and the noise. The product is us, not Facebook. It's not the Twitter. The product is us.
It's pretty funny that Walmart's in McKinney. If you bring a TV through the garden area, the McKinney police will be waiting for you on the outside. That seems to be the exit that people try to take them out of when they steal them.
Oh, they try to steal them through the garden area because they're not.
Yeah. So,
well, I bought a monitor, and it shows kind of my ignorance, but a little 23-inch monitor. We were somewhere in our van, and I forgot the monitor, so I bought another one, whatever. Anyway, I got the thing out of the store, and I realized that it still had the anti-theft band on it. The little button thing. And so I learned what that was all about. When I got back to our campsite, there I was, and so I pulled the thing off, and it starts squawking. And I realized I could have just absolutely beaten it to death, but I finally figured out that I just dipped it in a cup of water, and that quieted it. But it went for hours submerged in water. I added salt to the water, and it kept on. And even after it was dead, I pulled it out. I pulled this little beepy thing out of the thing, and then about an hour later, it's like, But I
Probably
made sure I had my
GPS
receipt
cord.
because I figured, maybe this thing is transmitting a signal and somebody's going to show up. Sir, did you pay for that?
The helicopters are gonna land on your website.
And you kind of destroy that transmitter.
I've been watching a lot of
Coca-Cola, though.
been watching a lot of different series that are coming on to Netflix, and one of them happened to be Treadstone, which is a spinoff from all the Bourne Supremacy and Bourne, all those kind of things, right? And well, we got to, and it just occurred to me what you're just saying, Ron, is that okay? This thing it's transmitting, and this thing's fairly big. If you look in the spy movies, and because I know how some things are going, they got radio transmitters on animals and things that will go a long ways, but they're RF, and you got to do triangulation to find them. In the spy movies, you have this thing that's a grain of rice that's shoved between something and you don't even know it's there, and you're seeing it from space, and it's blowing up it's coming in like it's I don't know, like I'm next door with a bullhorn, and like, no, I mean. I sure we can get low power stuff, but that doesn't have enough power to make it out of the atmosphere, let alone to be detected by anything.
Yeah, but all it has to do is be good enough to talk to your cell phone, and your cell phone's going to squeal on you.
That
so
is
any device that's within a few feet. So if you think about it, we've had it. It's over for us. I mean, yeah, nothing. It can be the grain of rice, not even a grain of rice.
There's no privacy.
Yeah.
Yeah, but I thought the grain of rice things, don't they use nuclear like isotopes, and they're detected by detectors that are
you're looking for the ionizing radiation that's coming off of those things?
Yeah.
No, actually, back in, I think it was in the 90s, maybe, Fujitsu released, what are the, I forgot, I just had a brain fart. What are the things that they put in